For 410 days, a piece of ground on Fifth Avenue held the attention of a city that rarely looked up long enough to notice anything at all. And when those days had passed, there stood above the street a tower taller than any structure raised by human hands before it. 1,250 feet of steel and limestone climbing into weather that no building had ever previously touched. It is worth pausing on that fact before anything else is said, because everything that follows in this story bends back toward it. A building of more than 102 stories, containing enough steel to have built a second, smaller tower from its excess alone, was conceived, designed, and completed in roughly the time it takes many modern projects merely to clear their permits. Engineers who study the record today, who have the benefit of a century of tools their predecessors never touched, still find themselves quietly unsettled by the pace of it. Not because the schedule was reckless, it was not, but because it was so precisely, so calmly, so relentlessly kept. This is the story of how that happened, and why, and what it asked of the men who built it. New York City in the year 1929 was a place already drunk on verticality. For 3 decades, the island of Manhattan had been discovering, almost by accident, that it could grow upward as easily as outward. And once that discovery had been made, there was no undoing it. Land was scarce and expensive, steel was strong and increasingly well understood, and elevators had solved the one problem that had kept buildings low since the beginning of building itself: the simple exhaustion of climbing stairs. By the late 1920s, the skyline of lower and midtown Manhattan had become something like a running argument conducted in stone and steel, each new tower a rebuttal to the one before it. The Woolworth Building had claimed the title of tallest in the world in 1913 and held it for 16 years, a Gothic spire of terracotta that seemed, at the time, to represent the outer limit of what ambition and engineering could achieve together. But by the time the 1920s were drawing to their close, that limit no longer felt fixed. It felt, instead, like a challenge waiting for the right combination of money, nerve, and design to overturn it. The most immediate of those challenges was rising a few blocks away on Lexington Avenue, where the Chrysler Building was climbing toward the sky under the direction of an architect named William Van Allen, working for the automobile magnate Walter Chrysler. That race, quiet in its public face, fierce in its private one, will occupy its own place later in this account. For now, it is enough to understand that the atmosphere of the city itself was one of contest, of towers watching each other rise, of newspapers and financiers alike keeping a kind of informal scoreboard. Into that atmosphere, at the corner of Fifth Avenue and 34th Street, came a piece of land with its own long history and, soon, its own improbable future. The site had been occupied for more than 3 decades by the original Waldorf Astoria Hotel, a grand and heavily ornamented building that had itself once represented the height of New York luxury and ambition. By the late 1920s, the hotel's owners had decided to relocate uptown, and the old building, with its 2 towers, its ballrooms, its accumulated decades of society dinners and quiet negotiations, was sold and marked for demolition. It is a detail worth sitting with for a moment. That the ground beneath what would become the tallest building on Earth was cleared not through any grand foresight about what would replace it, but through the ordinary churn of a city that was always, in those years, tearing down its recent past to make room for something taller. The Waldorf Astoria came down in the early months of 1929, its stone and timber hauled away, its foundations exposed to the open air for the first time in a generation, and the lot sat briefly empty, a rare piece of quiet at one of the busiest intersections in the world, waiting to see what would be asked of it next. What was asked of it, it turned out, was something without real precedent. The men behind the project were, on one side, a financier named John Jacob Raskob, a former executive at General Motors who had made his fortune in the machinery of industry and now wanted, it seems, to make a different kind of mark entirely. One built not of automobiles but of steel and stone, rising higher than anything a rival company or a rival city could claim. On the other side stood Alfred E. Smith, known to nearly everyone simply as Al Smith, the former governor of New York, a man of considerable public reputation who lent the project both his name and a certain civic legitimacy. Together, through a company formed for the purpose, they set out to build not merely a tall building, but the tallest building, a structure whose height would not simply serve commerce, but would stand, quite deliberately, as a statement. The architects entrusted with translating that ambition into working drawings were the firm of Shreve, Lamb and Harmon, led by William Lamb, a designer known for his discipline, his speed, and his instinct for structural clarity over unnecessary ornament. It was Lamb who would take the client's demand for height and turn it into a buildable plan, one that could rise not in years, but in months. And it is worth naming these men softly here, at the beginning, because everything that follows in this story is, in some sense, the record of what they set in motion. The building they intended to raise would come to be known as the Empire State Building, a name drawn from the old nickname for New York itself. And from the very first conversations about its design, the goal was stated almost bluntly. It must be taller than the Chrysler Building, taller than the Woolworth Building, taller than anything yet conceived. What makes the story remarkable is not simply that this goal was achieved, but the manner in which it was achieved. Through a construction schedule so tightly disciplined, so carefully sequenced, that steel could rise at a rate of more than 4 stories a week during the building's fastest stretches, with materials arriving at the site in a rhythm closer to a factory assembly line than to a traditional construction project. Engineers who have studied the surviving records of the build, the shipping manifests, the site logs, the daily counts of riveters and steelworkers moving across the frame, still describe the pace with a kind of quiet disbelief, because so little about it was improvised. It was a schedule kept not through chaos or overwork alone, but through an almost obsessive discipline in planning, one that anticipated where every beam and every rivet would need to be before it arrived. That discipline, and the men who enforced and executed it, will occupy much of what follows in this account. But before any of that discipline could be applied, before a single column of steel could be set into place, there was the matter of the ground itself. What lay beneath Fifth Avenue, what the old hotel's foundations had left behind, and whether the bedrock of Manhattan could truly be trusted to carry a weight the island had never been asked to bear. There was the matter of the drawings, still being revised even as demolition crews cleared the last of the old hotel's stone. There was the matter of steel mills in Pittsburgh, quarries in Indiana, and workshops across the eastern seaboard, all of which would need to be drawn into a single coordinated rhythm, long before the first crane rose above the empty lot. And there was, above all, the matter of time, a deadline set not by necessity, but by ambition, a determination that this building would rise faster than anyone believed possible, in defiance of every previous record for a structure of its size. It is this quiet, staggering fact that opens the story properly, that a tower taller than any before, it was raised, from bare earth to finished spire, in a span of scarcely more than a year, 410 days from the first steel to the building's completion. An achievement that still occupies engineers and historians who return to its records looking for the seams, the shortcuts, the places where the schedule must surely have been exaggerated, and find, again and again, that it was not. Before we follow the frame as it climbed toward the clouds, before we meet the riveters who walked its beams in open air 1,100 feet above the street, before we watch it overtake the Chrysler Building in a finish few in the city even saw coming, It is worth simply sitting for a moment with the shape of the challenge as it stood in the early months of 1929. An empty lot, a set of drawings, a wager against the sky, and a small group of men who believed, with a calm and unshaken certainty, that it could be done. If you find comfort in stories like this one, patient chronicles of the great structures raised by human hands across the centuries, you're welcome to stay with this channel and join us again for the next. For now, let us return to that empty lot on Fifth Avenue and to the men who looked at it and saw already a tower reaching into the clouds. To understand why such a tower rose at all, one must first understand the city that demanded it and the particular restlessness that had settled over its builders and financiers in the years following the First World War. New York in the 1920s was a city that had discovered, almost by accident, that height itself could be a form of speech. A tall building said something about the men who raised it, about their reach, their confidence, their willingness to spend fortunes on steel and stone simply to stand a little closer to the clouds than their neighbors. It was not, in the strictest sense, a practical impulse. Office space could be had at more modest elevations, and many of the men who financed these towers understood the economics of height only imperfectly, if at all. But there was something else at work, something closer to civic pride, or perhaps to a kind of collective vanity that the city itself seemed to encourage. Manhattan's narrow island geography, its dense grid of avenues, had already begun to push its architecture upward rather than outward, and by the time the 1920s drew to their strange and fevered close, the skyline had become a kind of ledger, each new tower a notation in an ongoing argument about who could climb highest. Nowhere was this argument more pointed than in the quiet, unspoken rivalry that had begun to take shape between two projects rising within walking distance of one another. Blocks away from the empty lot on Fifth Avenue on East 42nd Street, the architect William Van Allen was already engaged in the design of a tower for the automobile magnate Walter Chrysler, a building that would eventually crown itself with a stainless steel spire of remarkable and deliberate drama. The men behind the Fifth Avenue project were aware of this rival tower long before either building had risen far above its foundations, and though none of them spoke of it in terms so plain as a race, the timing of their own ambitions cannot be separated from what was happening at 42nd Street. It is worth pausing here, gently, to note that history does not always offer clean documentation for the emotions of its actors. No letter survives in which John Jacob Raskob declares outright that he intends to surpass Walter Chrysler's tower, and the surviving record, thin and imperfect as it often is in matters of personal motive, cannot fully confirm the shape of what passed between these men in private conversation. But the circumstantial evidence is difficult to ignore, and generations of historians have treated the rivalry as real, if never quite spoken aloud in the surviving papers. It was into this atmosphere of quiet architectural competition that Raskob, a man who had made his fortune first at the DuPont Company and then as an executive at General Motors, brought his restless energy and his considerable capital. Raskob was not an architect nor an engineer, and he claimed no particular expertise in the physics of steel or the mathematics of wind load. What he possessed instead was an instinct for scale, a businessman's appetite for the largest possible statement, and according to the accounts that have survived him, a habit of posing questions that were disarmingly simple on their surface and enormously complicated in their implications. It is in this spirit that the most enduring anecdote of the building's origin has come down to us, repeated so often in the decades since that it has taken on the texture of legend, though its precise wording cannot be verified against any contemporary transcript. The story holds that Raskob turned to his architect, William Lamb, and asked him plainly how tall a building could be made to stand, not how tall a building should be. or how tall the site could reasonably support given the economics of rentable floor space, but simply how tall such a structure could physically rise before some limit of engineering or material forced it to stop. Whether the question was asked in precisely those words, in a single conversation or across several, the sources disagree, and no verbatim transcript exists to settle the matter. But the spirit of the question, calm and audacious in equal measure, aligns closely enough with everything else known of Raskob's temperament that most historians have been content to accept it as broadly true, even while acknowledging that the exact scene has likely been smoothed and simplified by decades of retelling. The question itself, whatever its precise wording, arrived at a moment in American financial history that now reads, in hindsight, as almost unbearably poignant. The plans for the tower on Fifth Avenue were drawn up and financing arranged in the spring and summer of 1929. In an atmosphere of capital markets flush with confidence, credit extended freely, and a widespread public faith that the prosperity of the decade had no natural ceiling. Stock prices had climbed for years with what seemed, to many observers of the time, an almost inevitable momentum, and men like Raskob, comfortable in the upper reaches of American industry, had every reason to believe that a project of this scale and expense would find itself amply rewarded by the office market of the years to come. The building's financing was arranged, its steel ordered, and its construction schedule set in motion in the months immediately preceding the stock market's collapse in October of that year. There is a strange and sobering symmetry in this timing, one that no participant in the project could have anticipated as the drawings were being finalized. The tower that would come to be seen in later decades as one of the great symbols of American ambition and resilience was in fact conceived and financed at the very edge of the country's greatest financial catastrophe. And it would rise, floor by floor, through the early and bewildering years of the Great Depression, its construction site becoming almost accidentally a kind of monument to persistence in the face of collapsing certainty. This was not, the record makes clear, part of anyone's original design. It was simply the timing history handed to the men involved, and they proceeded, largely because the money and the steel had already been committed before the depth of the coming crisis was understood. Among those men, few figures carry a legacy as layered as Alfred E. Smith, the former governor of New York, who had run for the presidency in 1928 and lost, and who now found himself installed as the public face and president of the company formed to build the tower. Smith brought to the project a political legacy built on decades of service to the people of New York, a reputation as a reformer and a man of the streets who had risen from a difficult childhood on the Lower East Side to the governor's mansion in Albany. His presence lent the tower a kind of civic legitimacy that Raskob's business connections alone could not have provided, and his popularity with the public made him a natural spokesman for a project that would, in time, need every ounce of public goodwill it could summon. Smith's role was largely one of public representation rather than technical oversight, and the historical record treats him with a certain gentle respect. A man whose political career had just reached its most painful and public defeat, now given a new stage on which to stand, however different in character from the one he had lost. Behind Smith and Raskob stood the architects, a group whose temperament could not have differed more sharply from the restless drive of the men who financed them. The firm of Shreve, Lamb and Harmon approached the commission with a discipline that bordered on the monastic, treating the question of height not as an occasion for spectacle, but as a problem to be solved through careful, repeated iteration. William Lamb, who bore primary responsibility for the design, was known among his colleagues as a man of few words and exacting habits, someone who preferred the quiet certainty of a well-proportioned floor plan to any grander rhetoric about towers and skylines. It was said of him, by those who worked closely with him in those months, that he approached each new sketch as a craftsman approaches a familiar tool, refining rather than reinventing, until the design had been reduced to its most efficient and logical form. The drafting rooms where this refinement took place have been described, in the recollections of those who worked there, as spaces of quiet and sustained concentration. High-ceilinged rooms lit by long windows, drafting tables arranged in careful rows, each surface holding the beginnings of what would eventually rise as steel and limestone. It was here, through the late spring and summer of 1929, that the tower existed only as a set of lines on paper, revised again and again as the architects worked through successive schemes. Discarding early designs that failed to answer the practical demands of usable floor space, natural light, and structural economy. The final design, when it emerged from this process, was notable less for any singular flourish of invention than for its remarkable simplicity, a stepped and set-back massing that rose from a broad base to a slender shaft, crowned eventually by a spire, whose purpose, at the time of its conception, remained a matter of some debate, even among the men who designed it. In these early months, before a single foundation had been excavated, the entire ambition of the project existed nowhere but in these rooms, in ink and graphite, and the patient, unhurried logic of men who believed that height, however extraordinary, was simply a problem of proportion waiting to be solved. The firm entrusted with translating that ambition into working drawings was Shreve, Lamb and Harmon, an office that had, by the late 1920s, already accumulated a quiet reputation for tall buildings, raised with unusual economy of both material and time. Richmond Shreve, a New Englander by upbringing and a man of methodical temperament, had spent years refining the administrative machinery of large architectural practice, believing that a building's success was determined as much by the efficiency of its production as by the elegance of its silhouette. William Lamb, who would in time be remembered as the principal designer of the tower, had studied in Paris and carried with him an appreciation for classical proportion that he had learned to translate into the vocabulary of American steel construction. Arthur Loomis Harmon, the third partner, brought to the office an eye for massing and detail that had already found expression in the Shelton Hotel, a building whose stepped profile had shown, some years earlier, how the setback requirements of the city's zoning laws might be turned from a legal constraint into an aesthetic principle. Together, these three men had, by the time the Empire State Commission arrived, already worked on a number of substantial towers, and they approached the new task not as an opportunity for radical invention, but as a chance to refine methods they had been developing for the better part of a decade. Their prior experience with tall buildings had taught them that height alone impressed no one for long, and that what endured, in both the eye of the public and the ledger of the owner, was a structure whose every foot of steel and every ton of stone served a purpose that could be measured, defended, and repeated. It was this instinct for repetition, more than any singular architectural flourish, that would come to define the language of the building as it emerged from their drafting rooms that winter. The style the architects settled upon belonged to the broader current then moving through American commercial architecture, a manner that historians would later gather under the term Art Deco. Though the men drawing the elevations in 1929 would not have used that phrase themselves. What mattered to Lamb and his colleagues was not fashion but function expressed with restraint. Vertical piers of limestone and granite rising uninterrupted past the windows, drawing the eye upward in long, unbroken lines. A minimum of applied ornament, and what ornament there was rendered in simple geometric relief, rather than the historical borrowings of an earlier generation of skyscrapers. And a general avoidance of anything that might slow the pace of construction for the sake of decorative effect. This was elegance chosen deliberately for its compatibility with speed. Every recessed spandrel, every simplified cornice, every flattened pilaster was a decision made with the schedule as much as the skyline in mind. The architects understood that a design rich in variation, requiring different details on different floors, would multiply the labor of both the drafting room and the building site many times over. And so they pursued instead a vocabulary that could be stated once and repeated with only minor variation from the 5th floor to the 85th. In this way, the aesthetic of the tower and the economics of its construction were never separate considerations. They were, from the earliest sketches, the same problem addressed twice. That unity found its clearest expression in the decision to build upon a repeatable, modular steel frame, an approach that departed from the more individually tailored engineering of many earlier tall buildings. Rather than designing each floor's structural bay according to its own particular requirements, the architects and their engineering collaborators settled on a standard grid, a consistent spacing of columns that could be repeated with only slight adjustment as the tower rose and tapered. This modularity meant that once a typical floor's structural drawings were complete, the same essential drawings could be issued again and again, with the fabricators in Pittsburgh and elsewhere producing the same families of steel members in quantity, rather than crafting a bespoke assembly for every level. The efficiency this created was not merely a convenience for the drafting room. It shaped the entire logistics of the project, allowing steel to be ordered, fabricated, shipped, and erected according to a rhythm that would have been impossible under a more individualized design. It was, in its way, an early and instructive lesson in what would later be called industrial standardization applied to architecture, though the men practicing it in 1929 thought of it simply as good sense. Why solve the same problem 80 times when it could be solved once and repeated with confidence 80 times over? Yet a design, however elegant or efficient on paper, remains only a design until it is placed in the hands of men capable of building it. And it was here that the project found its second great asset in the firm of Starrett Brothers and Eakin. The Starrett name already carried considerable weight in the building trade. Brothers William and Paul Starrett had each, in earlier years, supervised the construction of some of the largest structures in New York, and their firm had cultivated a reputation less for architectural invention than for a kind of disciplined, almost military precision in the management of large and complex sites. Andrew Eakin, who joined them as a partner and would serve as the project's chief of construction, brought to the venture an exacting attention to scheduling and sequence that would prove essential once steel began to rise. The reputation of Starrett Brothers and Eakin rested on a simple premise: that a building site, properly organized, could be made to run with the regularity of a factory floor, each trade following the one before it, in a sequence so carefully timed that no crew ever stood idle waiting for another to finish, and no material ever arrived before the moment it was needed. This was not a glamorous skill, and it earned few headlines in the architectural press, but it was, in the estimation of those who had watched the firm work on earlier towers, worth more to the success of a tall building than any flourish of design. When the owners of the Empire State Project searched for builders capable of matching the architect's ambition for speed, it was this reputation for precision, tested and proven on smaller commissions, that made Starrett Brothers and Eakin the obvious choice. All of this, the elegant modular design and the disciplined construction firm alike, existed against a backdrop of considerable public skepticism, for the ambitions of the project's backers were, even by the standards of a city already accustomed to tall buildings, extraordinary. There were engineers and critics in those years who questioned openly whether a structure of the height now being proposed could be built at all within any reasonable span of time, and whether, once built, it could be occupied safely, its elevators and stairwells and water systems functioning at a scale no one had yet attempted. Some pointed to the practical difficulties of construction at such heights, wondering how materials could be lifted, in sufficient quantity, fast enough to keep pace with the schedule the owners had announced. Others raised more speculative doubts, questioning whether a tower of such unprecedented scale might sway dangerously in strong wind, or whether the very ground of Manhattan could bear the accumulated weight of so many hundred feet of steel and stone rising from a single site. The financial press, too, wondered aloud whether so much office space, arriving all at once into a market already showing signs of strain, could ever be filled with tenants, a doubt that would prove, in the years immediately following completion, to carry rather more substance than the structural concerns that had occupied the engineers. To these doubts, voiced in newspapers and at dinner tables and in the offices of rival architects, Shrove, Lamb and Harmon offered no public rebuttal beyond the steady production of drawings. Theirs was a quiet confidence, expressed not in argument but in calculation, in the patient accumulation of load tables and wind pressure studies and structural sections that addressed each concern not with rhetoric but with numbers. When asked whether the building could stand against the wind, the answer was not a reassurance but a diagram, a demonstration of how the steel frame's continuous riveted connections would distribute lateral forces down through the structure to the foundations below. When asked whether the schedule was realistic, the answer was a chart showing the sequence of trades and the anticipated rate of rise, floor by floor, week by week. This was the temperament of the age's structural engineers at its most characteristic: an unwillingness to meet doubt with assurance alone, and an insistence that the proof of a building's soundness lay in the arithmetic that preceded it, rather than in the confidence of the men who had drawn it. It was a confidence that asked to be judged only by results, and in the months that followed, as excavation began and the first columns of steel were readied for shipment from the mills of Pennsylvania, that judgment would begin, slowly and irreversibly, to be rendered in the language the engineers themselves had always preferred. In tonnage delivered, in floors completed, in days elapsed, and in the plain, unadorned record of a schedule that either would or would not be kept. Before any of that arithmetic could be tested, there was a hotel to remove. The site at the corner of 5th Avenue and 34th Street had for more than 3 decades carried a different kind of ambition altogether. The old Waldorf Astoria, a vast and ornamented pile of guest rooms and ballrooms that had, in its own era, represented the height of what a building might promise a city. It had hosted diplomats and industrialists, had served as a stage for the particular theater of old New York wealth, and had stood, by the standards of 1893, as a structure of considerable consequence. By the close of the 1920s, it had become something else, an obstacle, a mass of brick and plaster and old timber occupying ground that had been quietly acquired, piece by piece, by men who intended to put something taller in its place. The hotel closed its doors in the early months of 1929, and what followed was not spoken of in the language of tragedy, though something was undeniably ending. Wrecking crews arrived with the particular patience of men who understood that a building of that size could not simply be knocked aside, but had to be dismantled in sequence, floor surrendering to floor, until the ornamented shell that had taken years to raise was reduced, in a matter of months, to open sky and a churned field of rubble. The demolition itself proceeded with a thoroughness that mirrored what would follow. Salvageable materials, marble, ornamental ironwork, fixtures of a certain quality, were set aside and, in some cases, sold or repurposed, a practice not uncommon for buildings of the old hotel's stature, though the bulk of what came down was simply carted away, wagon and truckload by load, until the corner that had for a generation been known for chandeliers and doormen stood empty and raw, exposed to the weather in a way 5th Avenue had not seen it in living memory. It was into this cleared ground, and not before, that the real labor of the site could begin. For beneath every structure that hopes to rise with any confidence lies a question that ornament and marble can never answer. What precisely is being built upon? This was where Manhattan, almost alone among the great cities of the world, offered something close to a gift. The island's bedrock, a metamorphic stone geologists call Manhattan schist, formed under pressures and heat many hundreds of millions of years in the past, and folded into its present density through forces no engineer of 1929 needed to fully understand in order to appreciate, lay beneath much of the borough at depths that varied considerably from one neighborhood to the next, rising close to the surface in the area that would become Midtown, dipping far deeper toward the lower end of the island and beneath what had once been marshland further uptown. It was this uneven but often shallow bedrock that had already made possible the particular skyline New York was beginning to acquire, allowing foundations to be sunk directly into solid stone rather than floated, as engineers elsewhere so often had to float them, on pilings driven into soft or uncertain earth. The presence of the schist did not remove the need for care, but it changed the nature of the problem in a way that mattered enormously to men contemplating a tower of the height now being proposed. A building could only be as tall, in any honest and lasting sense, as the ground beneath it was willing to permit, and here, at this particular corner of Fifth Avenue, the ground was prepared to permit a great deal. That permission was not assumed. It was tested, in the plain and unglamorous manner such things are always tested, through borings sunk into the earth at intervals across the site, months before demolition had even finished clearing the surface above. Engineers and geological consultants worked from a series of narrow test holes, extracting cores of soil and, eventually, of the rock itself, examining the samples for depth, density, and consistency, building a picture, column by column, sample by sample, of what lay hidden beneath the old hotel's foundations. The schist, they found, rose close enough to the surface across most of the plot to be reached without extraordinary difficulty, and where it was reached, it proved sound, firm, unbroken, capable of bearing loads that would have made lesser or more fractured stone entirely unsuitable for a building of this ambition. This was not a discovery that arrived with drama. It arrived in the form of reports, tables of figures, and the quiet, incremental confidence of men who had asked the ground a difficult question and received, boring by boring, an answer they could work with. It is worth pausing on what that confidence actually meant, because it is easy, from a distance of many decades, to imagine engineers of the era proceeding on faith or ambition alone. They did not. Every decision that followed, the depth to which caissons and footings would be sunk, the manner in which the load of 80-some floors of steel and stone and human activity would be distributed and carried down through the frame into the earth, the very geometry of the foundation plan, rested upon what those test borings had revealed. Where the rock proved deeper or less certain, in a handful of spots near the edges of the site, the foundation design was adjusted accordingly, footings extended, loads redistributed, so that the building's ultimate weight, once concentrated at ground level, would be carried by stone equal to the task at every point beneath it. This was engineering not as an act of imagination, but as an act of translation, taking what the borings had disclosed about a piece of ground barely visible to the pedestrians walking past on Fifth Avenue, and converting it into a foundation plan precise enough to support, without argument or later correction, more than 365,000 tons of finished structure. With the hotel cleared and the borings complete, the excavation proper began, and it proceeded with the same unhurried, methodical character that would come to define the entire project. Steam shovels and, in places, men working with hand tools where the machinery could not safely reach, cut down through the loosened fill and old foundation remnants of the Waldorf Astoria, removing earth and broken masonry in a slow descent toward the schist below. It was not glamorous work, and it was not swift by the standards later generations would come to expect of urban construction. But it was steady, And steadiness on this particular site mattered more than speed. Old foundation walls from the hotel had to be broken apart and hauled away. Utility lines running beneath the block had to be identified, in some cases rerouted, in others simply avoided by careful excavation around them. And throughout, engineers monitored the exposed rock face as it emerged, checking it against the borings that had predicted its depth and character, confirming section by section that what they had found in narrow cores months before matched what now lay open to the sky across the width of an entire city block. Once the rock was exposed and cleared to the required depth, the laying of the first footings began. Broad, thick pads of concrete set directly upon the schist, engineered to receive the immense, concentrated loads that would eventually descend through the steel columns above them. These footings were not uniform. Their size and depth varied according to the load each would ultimately bear. Larger and deeper beneath the points where the heaviest columns of the frame would eventually rise. More modest where the loads to be carried were correspondingly lighter. Reinforcing steel was set within the concrete before it was poured, embedding within each footing the beginning of a structural continuity that would, floor by floor, connect the very bedrock of Manhattan to the highest steel yet to be fabricated in the mills of Pennsylvania. There is a particular kind of quiet in this stage of any great building's life, a stage the public rarely sees and rarely thinks to ask about, in which the entire ambition of a project, the height, the speed, the record that will one day be claimed, depends entirely upon concrete curing correctly around steel reinforcement, in pits that will, within a year, be buried far beneath finished lobby floors and never seen again by anyone. For the engineers overseeing this work, there was a satisfaction in it that had little to do with triumph and everything to do with confirmation. The site had been surveyed, questioned, tested, and finally opened, and at every stage the ground had answered as the borings had promised it would. This was not fortune in any romantic sense. It was the simple, fortunate coincidence of ambition meeting geology in a city where geology happened, in this particular location, to be generous. Other cities, and even other parts of Manhattan itself, would have demanded far more elaborate and costly foundation work. Pilings driven deep through soft soil, caissons sunk through water-bearing ground, foundations engineered around uncertainty rather than upon confirmed solid stone. Here, at 5th Avenue and 34th Street, the schist had risen to meet the builders at a depth that was, by the standards of such undertakings, almost obliging. The engineers recorded this not with celebration, but with the same plain notation they applied to every other completed stage of the work. The footings were in, the rock had proven sound, the foundation plan had held without significant revision, and the building, whatever its final height would prove to be, now had beneath it exactly what its designers had hoped to find. The ground, in the end, had been ready before the steel ever arrived to test it, and it was upon that unglamorous, unseen readiness that everything visible about the building would eventually depend. Even as the last of the excavation work was being closed and inspected, the true material of the building's ambition was already taking shape many hundreds of miles away, in furnaces and rolling mills that had never seen Fifth Avenue and never would. The structural steel that would give the tower its skeleton was ordered from mills scattered across Pittsburgh and the industrial valleys that fed it. Mills that had spent decades perfecting the rolling and shaping of steel members. For bridges, for factories, for the great commercial buildings that had already begun to reach upward in Chicago and New York. This was not steel bought in bulk and shaped later. Every beam, every column, every diagonal brace had been specified in advance by the engineers, drawn out on paper with exact dimensions and load tolerances. And the mills were asked to deliver members that matched those drawings almost to the fraction of an inch. The tolerances were not generous. A column that was meant to carry a certain number of tons through 40 or 50 stories of accumulated weight above it could not be allowed to vary meaningfully from its specified cross-section, and the men who inspected incoming steel at the mill and again at the site were trained to notice the kind of small deviation that a less demanding project might have overlooked. The steel itself was rolled in standard shapes: the wide-flanged beams, the built-up columns, the latticed girders, but assembled according to a design that treated the building less as a single continuous structure and more as a sequence of vertical bays, each one calculated separately and then joined to its neighbors, so that the load of the whole tower moved downward through a coordinated lattice of individual members, rather than through any single continuous spine. This approach, standard by then in the tall building trade, but still demanding enormous precision at this scale, allowed the steel to be fabricated in advance, off-site, in pieces small enough to move by rail and large enough to erect quickly once they arrived. The mills worked from shop drawings that translated the architects' and engineers' intentions into instructions a foundryman could follow, and those drawings themselves ran to many thousands of individual sheets, each one accounting for a single piece of steel among the tens of thousands that would eventually be needed. While the steel took shape in Pittsburgh, another material was being drawn out of the ground with equal care, though for entirely different reasons. The limestone that would clad the building's exterior came from quarries in southern Indiana, a region that had supplied stone for public buildings and institutions across the country for decades, and had built a quiet reputation for producing limestone of unusual evenness, strength, and color. The architects had chosen this stone deliberately, not simply because it was available in the necessary quantity, though that mattered too, but because its pale, faintly warm grey carried a dignity that dark granite or ornate terracotta could not offer at this scale. A tower of this height, they understood, would be visible from great distances and from nearly every angle a person in the city might occupy, and its colour would become, in effect, part of the skyline's daily conversation with the light. Limestone took the sun differently than stone that many earlier skyscrapers had used. It did not glare, and it did not disappear into shadow, but held a steady, almost architectural calm across the changing hours of the day. The quarries themselves were substantial operations, cutting stone in blocks far larger than what any single building typically required. And the logistics of moving that much stone from inland Indiana to the middle of Manhattan required the same rail infrastructure that was already carrying the steel eastward. The limestone did not arrive as raw blocks to be carved on site, in the manner of older stone buildings. It arrived already cut and finished according to precise specifications, shaped at the quarry into the exact panels and trim pieces the building's cladding system called for, so that installation on site could proceed at the same disciplined pace as everything else. This was, in its own way, as much an exercise in industrial coordination as the steel frame itself, translating a natural material into standardized components that could be handled, hoisted, and set with the same rhythm as manufactured parts. Above the load-bearing steel and the limestone cladding, at the crown of the building where ornament rather than structure took over, the architects turned to materials that were still, in those years, novel within construction at this scale. The spire and much of the ornamental trim near the top of the tower were finished in aluminum and in a chrome nickel-steel alloy, materials chosen for reasons that had as much to do with the age's fascination with modern industry as with their practical qualities. Aluminum in particular was, at the time, still closely associated with aviation and with the emerging vocabulary of speed and machine-age progress, a metal that carried connotations of lightness and forward motion rather than the weight and permanence of traditional architectural materials. Using it as an exterior finishing material on a building of this scale was itself a statement, a visual argument that the tower belonged to a new era of construction rather than a continuation of the old one. Aluminum offered genuine practical advantages as well. It was light enough to be handled and installed at height without the enormous structural reinforcement that heavier ornamental metals would have demanded, and it resisted the corrosion and discoloration that could dull the appearance of a building's upper reaches within a few short years of exposure to weather. The chrome-nickel steel used alongside it offered a harder, more durable finish for elements exposed to greater wear. And together, the two metals gave the building's crown a bright, faintly silver quality that distinguished it sharply from the warmer stone tones lower down the tower. Neither material had been used at this scale in earlier tall buildings, and their presence at the top of the structure reflected a confidence on the part of both architects and engineers that new materials could be integrated safely into a design without compromising the building's overall performance or its schedule. Bringing all of these materials together at the volumes and on the timetable the project required demanded a logistical choreography almost as demanding as the engineering itself. The site occupied a full block in the middle of one of the busiest commercial districts in the country, and there was no meaningful space to store large quantities of steel, stone, or metal trim on site while waiting for it to be needed. Instead, deliveries were timed with an almost theatrical precision, coordinated so that a shipment of steel members would arrive by rail, be transferred to trucks, and reach the site at very nearly the hour it was scheduled to be hoisted into position, sometimes within minutes of the crane or derrick becoming free to receive it. This timing was not an incidental convenience. It was, by necessity, a central discipline of the entire construction effort. A site cluttered with stockpiled material would have slowed the movement of workers and machinery, created hazards underfoot, and eaten into the narrow margins that allowed the building to rise at the pace it did. The men responsible for logistics kept schedules that accounted for rail departures from the mills, transit times across the region, the unloading capacity of the site's limited street frontage, and the erection sequence of the steel gangs above, adjusting the timing of shipments as the building's needs shifted week to week. Trucks queued at specific times along the surrounding streets, delivering their loads in a sequence calculated to match the exact bay of steel or the exact course of limestone that was next in line to be set. It was, in effect, an early and highly disciplined example of what would later be recognized as just-in-time delivery, developed not from any abstract theory of efficiency, but from the plain necessity of building an enormous structure on a cramped urban site without the luxury of storage space or slack time. The reasons behind these material choices, taken together, reveal as much about the ambitions of the project as any account of its height. Steel was chosen because it could be fabricated with precision off-site and erected quickly once it arrived, allowing the building's frame to rise at a pace that would have been unthinkable with older construction methods relying on masonry-bearing walls. Limestone was chosen not simply for its structural suitability as a cladding material, but for the particular quality of light it offered, a calm and enduring paleness that suited the architect's vision of dignity rather than spectacle. Aluminum and chrome-nickel steel were chosen for their lightness, their resistance to weathering, and for the modern character they lent to the building's silhouette against the sky, a deliberate alignment with an age that prized speed, industry, and the machine. And the entire choreography of delivery, precise almost to the hour, was chosen because there was no alternative if the building was to rise as quickly as its schedule demanded. Every material decision, in other words, served a double purpose: structural and aesthetic, practical and symbolic, reflecting a building conceived not merely as a container of office space, but as a statement, in steel, stone, and metal, of what industrial civilization believed itself capable of achieving when its resources were gathered, timed, and assembled with sufficient discipline. The mills of Pittsburgh, the quarries of Indiana, and the emerging aluminum works of the era had each contributed their share to a structure that none of them, working alone, could have imagined standing complete. By the time the last deliveries of steel had begun arriving in their carefully numbered sequence, the ground at Fifth Avenue and 34th Street had already given way to a different kind of order entirely. One measured not in tons of material assembled, but in the rhythm of days themselves. It was in the early spring of 1930, with the foundation and lower framework already settled into the earth, that the true erection of the structural steel began in earnest, and with it a phase of construction that would come to be remembered, among engineers and laymen alike, as one of the most extraordinary sustained feats of building the modern world had yet produced. The steel did not simply rise. It rose according to a schedule so precise, so relentlessly maintained, that the building itself seemed at times less a construction than a kind of mechanism. Wound tight and set moving, each day adding its increment of height with the same quiet inevitability as a clock advancing its hands. The instruments of this rising were the derricks, tall and skeletal, mounted at the building's core and reaching upward through openings left for that very purpose in each successive floor. These were not fixed machines, content to labor from a single vantage point. They were travelers, climbing structures in their own right, dismantled and reassembled several stories higher as the frame beneath them solidified enough to bear their weight. A derrick would stand upon one level, hoist the steel required to complete several floors above it, and then, once its usefulness at that elevation had been exhausted, be taken apart piece by piece and raised to a new perch, higher still, from which the work could continue. In this way, the machines that built the tower were themselves constantly being rebuilt, following the frame upward in a kind of mechanical echo of the structure's own growth, so that at any given moment during the steel erection, an observer looking up from the street would have seen not a static silhouette, but a shifting arrangement of booms and cables, always in motion, always climbing. The steel itself arrived from the rail yards and marshalling points in pieces already fabricated to the precise dimensions called for in the shop drawings, each beam and column marked with a code that told the riggers exactly where in the frame it belonged. There was no shaping or fitting to be done at the site beyond the final positioning. The work of cutting and drilling had been completed weeks earlier, in the mills, according to specifications generated with such exactness that a piece manufactured in Pittsburgh could be hoisted into place in Manhattan and find its bolt holes aligning within a margin, so slight it was measured in fractions of an inch. This was the quiet triumph beneath the visible spectacle of the rising frame. That so vast an undertaking, involving so many thousands of individual members, could be assembled with the same confidence one might bring to a far smaller and simpler structure, because the tolerances had been established long before the steel ever left the ground. What struck observers most forcibly, however, was not the precision alone, but the pace at which that precision was maintained. In the most productive stretches of the erection, the frame climbed at a rate that had rarely been matched in the history of tall building, and has seldom been matched since. Reports from the period, drawn from the site logs kept by the general contractors and later compiled by engineers eager to understand how such speed had been achieved, describe weeks in which 4 or more floors of structural steel were raised, riveted, and made ready for the next stage of work. A pace that meant the building was, quite literally, growing faster than a person could climb its stairs to keep watch on progress from one week to the next. Visitors returning to the site after only a handful of days sometimes found the tower already unrecognizable from their previous visit, its silhouette advanced by a full story or more. The derricks that had crowned its summit on their last inspection now buried within the completed frame beneath a fresh crown of steel still being fitted into place. This velocity was not the product of haste alone, nor of some reckless determination to finish quickly regardless of cost. It was the product of choreography, a sequence of trades moving across the rising frame in careful order, each following the other with a discipline that made the speed possible rather than dangerous. The ironworkers came first, the men who caught the beams as they swung in from the derricks and guided them into position, securing them temporarily with a handful of bolts driven through matching holes until the steel could be more permanently fastened. Behind them came the riveting gangs, 4 men to a team by the customary arrangement of the trade. A heater, who kept a small forge glowing with coke and worked the rivets to a searing orange heat. A catcher, who received the heated rivet in a metal cone or bucket after it had been tossed, sometimes across considerable distances of open air from the heater's tongs. A bucker-up, who held a heavy bar against the head of the rivet from one side of the joint while it was driven. And the riveter himself, who drove the opposite head into shape with a pneumatic hammer. The sound of the tool's rapid hammering becoming, over the course of the project, one of the defining noises of the entire construction, audible for blocks in every direction and woven into the daily soundscape of the neighborhood as thoroughly as traffic or church bells. The heated rivet, tossed through open air from heater to catcher, was itself a small marvel of practiced coordination, one that depended entirely on trust built through repetition. The heater's throw calibrated over months of shared labor to land precisely in the catcher's cone, even at heights where a gust of wind or a moment's inattention could send the glowing metal astray. Photographs and film footage from the period, along with written accounts from journalists permitted onto the site, describe this exchange with something approaching reverence, marveling at the casualness with which men handled fire and steel hundreds of feet above the street, as though the danger inherent in the work had been so thoroughly absorbed into routine that it ceased to register as danger at all, at least to those performing it. Behind the riveting gangs came the plumbers up, whose task was to verify that each new section of steel stood true, vertical where verticality was required, level where levelness mattered, aligned within the tolerances the engineers had specified, before the temporary bolts were removed and the rivets driven home permanently. This verification was not a formality. A column raised even slightly out of true, if left uncorrected, could compound its error upward through every subsequent floor, so that a small deviation at a low level might become, by the time the frame had climbed 20 or 30 stories higher, a serious structural problem requiring far more difficult and costly correction than the original misalignment would have demanded. The plumbers up, working with transits and plumb lines, caught these deviations while they remained small, adjusting the position of a beam by degrees so fine they were scarcely visible to anyone but the men measuring them before signaling the riveting gangs to proceed. And behind all of these trades, coordinating their movements and ensuring that the steel arrived exactly when it was needed, rather than a day early to sit idle or a day late to stall the sequence, stood the hoisting engineers who operated the derricks themselves, along with the timekeepers and superintendents who tracked the arrival of each shipment against the master schedule. Their work was less visible than that of the riveters or ironworkers, conducted largely from small operating platforms and site offices, rather than from the open steel itself. But it was no less essential to the rhythm that made the building's pace possible. A derrick idle for lack of steel to hoist represented lost time that could not easily be recovered. A derrick straining to hoist steel before the frame beneath it had been properly secured represented a hazard that could not be tolerated. The entire sequence depended on a continuous, almost musical coordination between the delivery of material, the operation of the machines, and the labor of the men on the steel, each element timed against the others with a precision that left remarkably little room for error and even less room for delay. It was this combination, the extraordinary speed of the work and the extraordinary precision required to sustain it, that gave the construction its particular character, and that has made it, in the decades since, an object of continued study among engineers interested in the history of building methods. Speed alone would have been unremarkable, even reckless, had it come at the cost of accuracy. precision alone, pursued without regard for pace, would never have permitted a building of this scale to rise within the span of little more than a year. What made the erection of the frame notable was that both were achieved simultaneously, each dependent on the other, the tolerances of fractions of an inch maintained, not despite the pace, but because of the discipline that pace demanded. At extreme height, with wind loads to consider, and the compounding effects of even minor misalignment growing more consequential with every additional floor, there was no margin for the kind of correction that might be tolerated in a lower, more modest structure. The rhythm of the rising frame, in other words, was not merely a matter of impressive speed. It was a demonstration that speed and precision, properly organized and choreographed among trades who trusted one another, absolutely need not stand in opposition. That a building could rise as fast as the derricks could climb and the rivets could be driven, and still stand true, floor after floor, against a sky that offered no forgiveness for error. The men who made this trust possible, who lived out this choreography hundreds of feet above the street, with an ease that struck every observer who paused to watch them, were the ironworkers, and among them a particular reputation had already taken hold by the time work began on Fifth Avenue. Many were Mohawk, drawn chiefly from the community at Kahnawake near Montreal, though other indigenous ironworkers from various nations also walked the beams, alongside a broader mix of Irish, Newfoundland, and native-born American workers who had entered the trade through the same hard apprenticeship of height and steel. The reputation of the Mohawk ironworkers in particular had been building for decades by 1930, since the days of the Dominion Bridge Company's work on the St. Lawrence in the 1880s, when it was observed, according to the accounts that survive, that a number of Kahnawake men showed an extraordinary composure at elevations that unsettled other workers considerably. Whether this composure reflected some special gift, as popular legend sometimes insisted, or simply a willingness to master a difficult trade passed down through families and reinforced by community pride. The historical record does not resolve with certainty, and it is worth resisting the more romantic versions of the story that circulated in newspapers of the era, which tended toward exaggeration. What can be said plainly is that these men worked the high steel with a calm efficiency that became, over the following decades, something of a defining feature of ironworking as a trade, and that by the time the Empire State Building rose, ironworkers of Mohawk heritage were a familiar and respected presence on nearly every major skeleton being raised in New York and beyond. Their wages, like those of the other trades on the site, reflected both the danger of the work and the union strength the ironworkers had built over the preceding years. A structural ironworker in 1930 could expect to earn in the range of $15 a day, a considerable sum by the standards of the time, and one that placed the trade among the better compensated forms of manual labor available anywhere in the country, particularly notable given that the broader economy had already begun its slide into the difficulties of the Depression. The pay reflected a simple calculation understood by everyone on the site. Not every man could do this work, and fewer still could do it well, and the building could not rise without them. A riveting gang, moving at its practiced pace, might drive several hundred rivets in a single day. And the men were paid, in part, according to the pace they kept, which gave every incentive toward the same steady rhythm that visitors found so remarkable to watch from the street below. The daily routine of an ironworker on the Empire State site began, as it did on any large structural job, with an ascent, first by hoist to whatever floor was currently receiving steel, and then, if the work required it, up ladders lashed to the columns or across the temporary planking that served as the only floor many of these men would stand upon for hours at a stretch. There was no elevator to the working level in the earliest sense. The derricks that lifted steel served the material, not the men, and much of the vertical travel across a working day was accomplished on foot, over structure that in places consisted of nothing more than the bare beams themselves, spaced according to the column grid and offering, to a man walking them, a path perhaps 8 or 10 inches wide, with the street a very great distance beneath. The physical demands of the work extended well past this simple matter of balance. A bucker-up spent his day braced awkwardly into the angle of a beam, holding a dolly bar against the head of a rivet, while the full force of the riveting hammer drove against it from the opposite side, a task that required considerable strength. Sustained over hours and performed, more often than not, in a posture that would have been uncomfortable even at ground level. A raising gang guided tons of swinging steel into position, using nothing more than hand signals, taglines, and a shared understanding built over months of working together. In wind that could shift a suspended beam unpredictably, and cold that could stiffen fingers needed for precise, split-second work. The riveting itself, which any observer of the rising frame would have found impossible to look away from, was organized around a crew of 4 men, each with a distinct role, and the entire operation depended on a kind of wordless coordination that visitors often compared, not inaccurately, to a form of dance. The heater's job was to tend a small coke or coal forge, often little more than a portable furnace set on the working floor itself, keeping a supply of rivets constantly at the correct heat. Glowing orange, soft enough to be driven, but not so hot as to burn through its structural strength. When a rivet reached the proper temperature, the heater would draw it from the forge with tongs and throw it in a practiced underhand toss across open space to the catcher, who waited at the point where the rivet was needed, sometimes a considerable distance away, and often across a gap where a misjudged throw could send a piece of hot metal falling toward the street. The catcher received the glowing rivet in a metal cone or simply in a heavy leather glove and metal container designed for the purpose, plucking it from the air with a motion that appeared, to those watching from below, almost casual, though it demanded exact timing and total concentration. He would then insert the rivet immediately into its pre-drilled hole in the steel, while the bucker-up, braced on the opposite side, held the dolly bar firmly against the rivet's head to provide resistance. The riveter then stepped in with his pneumatic hammer, driving the rivet's opposite end into a second head that would, once cooled, contract slightly and draw the joined plates or beams together with a grip, stronger than the rivet had possessed while merely resting in its hole. The sound of this operation, hundreds of rivets being driven across dozens of simultaneous crews scattered over the rising floors, was a defining feature of the building site, an almost continuous percussion that could be heard from blocks away, described by more than one contemporary account as sounding like a great mechanical heartbeat sustained across the better part of a year. Amid this demanding and dangerous labor, the human details recorded by journalists, photographers, and later oral historians offer a gentler picture of the days these men spent above the city. Meals were frequently eaten on the steel itself, men settling onto a beam with their legs braced or hanging, a lunch pail balanced beside them, taking their rest in precisely the position that would have caused a visitor vertigo simply to contemplate. Lewis Hines' photographs from the site, among the most enduring images of the entire construction, captured exactly this. Men reclining on girders at a height where the streets below had reduced to a pattern of small shapes, sharing a sandwich or a thermos of coffee with the same unconcerned ease they might have shown at a curbside on 34th Street. Rest periods were brief, dictated by the pace of the work rather than any fixed schedule, and often taken collectively, a crew pausing together after completing a difficult lift or a demanding run of rivets before returning to the next task. Camaraderie among these crews ran deep, born necessarily from the fact that each man's safety depended absolutely on the competence and attention of the others. A catcher who missed his rivet, a signalman who gave an unclear command, a raising gang member who released a line a moment too soon, could each, in an instant, cost a life. This mutual dependence produced, according to the accounts of ironworkers themselves in later years, a particular quality of trust that extended beyond the working day. With many crews staying together across multiple jobs over the years, moving as units from one rising skeleton to the next, across the city and sometimes across the country, their reputations and friendships built and tested one beam at a time. The dangers accepted as ordinary by these men are difficult, at this distance, to fully appreciate. Falls, dropped tools, swinging loads, sudden gusts that caught an unsecured plank. The litany of hazards was long, and safety measures by later standards were minimal, with safety belts and nets used inconsistently and often left aside by men who found them cumbersome to the work. And yet the casualty record of the Empire State Building's construction, when measured against the scale and speed of the project, was remarkably low. Contemporary accounts and later historical review generally place the number of deaths during construction at around 5 or 6, a figure that startled observers even at the time, given popular expectation, fed by tales of earlier skyscraper projects and bridge works with far higher tolls. That a building of this height, raised in so short a span, might claim dozens of lives. The precise reasons for this comparatively favorable record are not fully settled in the historical accounts, though many point to the extraordinary skill and discipline of the ironworking crews themselves. The careful organization Starrett Brothers and Eakin imposed on every phase of the work, and perhaps some measure of good fortune that no single account can fully explain. What remains clear from every source that survives is that the men who walked the beams accepted the danger of their trade, not with bravado, but with a quiet professionalism, treating extraordinary height and considerable peril as simply the terms of their daily work, terms they had chosen and mastered, floor after floor, through a year that asked more of them than almost any building before it ever had. While the men who walked the beams above Fifth Avenue went about their daily work with that quiet professionalism, they were not alone in the sky. A few blocks to the east, on Lexington Avenue at 42nd Street, another tower was climbing at nearly the same pace, raised by another team of builders who shared the same ambition, though few of them would have described it so plainly at the time. The Chrysler Building had begun its own ascent months before ground was broken for the Empire State, and through the closing months of 1929, the two structures rose together, separated by less than 2 miles of City Street and by a rivalry that the public followed with unusual attention. Newspapers tracked the progress of each tower with the same interest once reserved for transatlantic crossings or heavyweight prize fights, though the contest here was slower, quieter, and measured not in rounds, but in stories added month by month. It was, in its way, a peculiarly American form of suspense. Two buildings, both funded by men determined to leave a mark on the skyline, both employing some of the era's most capable engineers, and both aimed, whether openly admitted or not, at the same target, which was simply to stand taller than anything else on Earth. The man behind the Chrysler Building, the automobile manufacturer Walter Chrysler, had commissioned the architect William Van Allen to design a headquarters that would announce his company's arrival among the giants of American industry. Van Allen, for his part, had a personal stake in the outcome that ran deeper than professional pride. His former partner, H. Craig Severance, was at that very moment engaged in his own race to build the tallest tower in Manhattan at 40 Wall Street, and the two architects, once colleagues, had become rivals in a contest that mirrored the larger one unfolding between their clients. As the towers on Lexington Avenue and Wall Street climbed through 1929, each side watched the other's height with evident concern, and it was in this atmosphere of professional and commercial competition that Van Allen conceived a plan that would remain hidden from public view until the final weeks of construction. The plan involved a spire, slender and gleaming, built not as a visible addition to be assembled at the summit in the ordinary way, but constructed in secret inside the very crown of the building, out of sight of the workmen on the street below, out of sight of rival architects and their surveyors, out of sight indeed of almost everyone except the small crew entrusted with its assembly. According to the accounts that survive, the spire's sections were carried up the elevator shaft and fitted together within the dome of the building over a period of weeks. A private construction project completed inside a completed structure, awaiting only the right moment to be lifted into place. When Severance's 40 Wall Street building was finished in the spring of 1930 and claimed the title of tallest building in the world, a claim it held for barely a month, Van Allen's answer emerged from the crown of the Chrysler Building. In late October of 1929, the spire was hoisted upward through the open lantern at the top of the dome and bolted into position in a matter of hours, a maneuver so quickly and quietly executed that it caught even the city's engineers by surprise. When the operation was complete, the Chrysler Building stood at a height of 1,046 feet, and for a brief season, it held the record its architect had worked in secret to secure. Word of the achievement reached the offices of Shreve, Lamb and Harmon within days, and the response it prompted was not one of alarm so much as recalculation. The architects and engineers behind the Empire State Building had designed their tower to reach a height of some 86 stories, sufficient by any reasonable measure to stand among the tallest buildings ever raised. But no longer sufficient, it now seemed, to claim the singular distinction that had become, almost by accident, the defining ambition of the project. The response that followed was neither hurried nor theatrical. There was no public announcement of a race, no press conference declaring an intention to reclaim a title. Instead, the architects returned to their drafting tables and began the quiet work of revision, examining how additional height might be added to a design that had already been calculated, engineered, and largely committed to structural steel that was, in some sections, already rising from the ground. The solution they arrived at was the mooring mast, a slender addition that would crown the building's 86 finished stories, with a further structure reaching more than 200 feet higher still. Publicly, the mast was presented as a practical innovation, a docking station for the airships that many believed, in that era of optimism about lighter-than-air travel, would soon carry passengers between cities and across oceans, in the manner that ocean liners then carried them between continents. The idea held genuine appeal to men like Alfred E. Smith, the building's public figurehead, who spoke of dirigibles mooring at the summit of the tower and passengers descending by elevator directly into the heart of Manhattan, a vision of the future that captured the public imagination, even as the engineers who would actually have to build the thing regarded it with rather more caution. Whatever the balance between genuine ambition and convenient justification, the mast served two purposes at once, and it is worth reflecting on how calmly this dual purpose was pursued. There was no fanfare in the way the addition was announced, no attempt to match the Chrysler Building's dramatic unveiling with a comparable flourish of its own. The revision appeared instead in the ordinary channels of professional practice, in amended drawings submitted to the building department, in revised structural calculations passed between the office of the architects and the steel fabricators, in the sort of incremental adjustment that a project of this scale absorbed as a matter of course. The mast would add height, and height, whatever its stated purpose, would settle the question that the Chrysler Building's spire had reopened. But it would be achieved through engineering rather than spectacle, through steady calculation rather than a hidden unveiling designed to startle a rival and capture headlines. It was, in this sense, a very different answer to a very similar problem, and it reflected something of the character that had guided the Empire State Project from its earliest planning, a preference for solving problems through method rather than through display. The structural integration of the mast required its own careful thought. since it could not simply be perched atop the building's frame as an ornament. The steel skeleton had to be extended upward in a manner consistent with the loads it would bear, accounting for wind pressure against a structure now reaching still further into the atmosphere above Manhattan, and accounting too, at least on paper, for the entirely novel stresses that might be imposed by an airship secured at its summit by a mooring line, straining against the tower in whatever wind happened to be blowing at that altitude on any given day. Engineers debated the practicality of this second consideration with rather more skepticism than the public statements of the building's promoters ever admitted. The difficulty of holding an airship steady against the updrafts that swirl around a tall building in a dense city, the danger of maneuvering a craft filled with hydrogen or, later, the scarcer and more expensive helium, into position near a mast surrounded by other towers and telegraph wires, and the sheer awkwardness of attempting to disembark passengers by a gangway suspended hundreds of feet above the street. All of these practical objections were raised within engineering circles even as the mast was being designed and built. Some accounts suggest the airship function was taken quite seriously by certain figures involved in the project, while others suggest it was understood from the outset as a secondary justification for a height that served other purposes entirely. The sources do not agree, and the truth very likely rests somewhere between sincere hope and convenient rationale, a combination not unusual in an age that mixed genuine technological optimism with considerable commercial calculation. What can be said with more confidence is that the mast was built to the same exacting standards as the rest of the tower, its steel frame calculated with the same patient rigor that had governed every other stage of the structure's rise, and that its addition transformed the building's final height to 1,250 feet, a figure that would stand unchallenged for more than 4 decades. The engineers who solved this problem left no dramatic account of the moment they settled on the final design, no record of triumph or relief at having answered the Chrysler Building's secret spire. There was, instead, only the steady continuation of the work already underway, the mast rising in its turn as one more phase in a construction schedule that had, from its very beginning, been organized around the discipline of doing one thing correctly before moving to the next, whatever else was happening on the skyline around it. Beneath that discipline lay a second building, invisible to the crowds who craned their necks on Fifth Avenue, and in some ways more remarkable than the one they could see. While the steel climbed and the riveters called their signals across the open floors, another army of workers moved through the completed levels below, threading the building with the systems that would let it breathe, drain, light itself, and carry its occupants skyward without a single one of them climbing a stair. Chief among these systems, and the one most likely to astonish visitors in the building's early years, were the passenger elevators, 64 of them by the time the building opened, arranged in banks that served different ranges of floors, so that no single shaft had to carry the entire weight of vertical travel from lobby to the 86th floor and beyond. The elevators themselves were driven by machinery that represented the accumulated engineering of decades, the culmination of a technology that had, within living memory of some of the older workers on site, made buildings of this height conceivable at all. Without a reliable means of lifting people quickly and safely past the 10th or 20th floor, the frame above might have risen just as easily, but it would have risen into uselessness, an architectural exercise with no practical way to inhabit its upper reaches. The elevators solved that problem so completely that few of the building's early tenants gave much thought to the marvel beneath their feet each time the doors closed and the car began its ascent, though the engineers who designed the system understood exactly how much depended on getting it right and how little room there was for error in a building where a stalled car might strand someone 80 floors above the street with no other way down. The shafts that carried these elevators did not appear after the steel frame was finished. waiting empty until some later stage of construction, but rose in careful coordination with the frame itself. Cut into the building's plan from the earliest drawings and left open through each successive floor as the steel columns climbed past them. This was not a small consideration. A building of this height needed not only elevator shafts, but plumbing risers to carry water up to distant floors and waste back down to the street, electrical conduits to bring power and light into thousands of individual offices, and ventilation passages to move air through spaces that would otherwise have no access to open windows on their interior sides. Each of these systems required its own vertical path through the building, and each path had to be planned before the steel went up, because steel columns, once riveted into place, could not easily be moved to accommodate a pipe or a cable run that someone had forgotten to include. The architects and engineers had resolved this problem months before ground was broken, working through the building's plans floor by floor to establish exactly where each shaft would run, how wide it needed to be, and how it would connect to the mechanical spaces that fed it, so that by the time steel began to rise, the questions of routing and space had already been settled, and the frame could go up around openings that were already accounted for, rather than being modified afterward to make room for systems no one had planned in advance. This foresight allowed something that had rarely been attempted at this scale before, which was the layering of trades so that plumbers, electricians, and elevator installers could begin their work on lower floors while the steelworkers were still raising columns dozens of stories above them. In a construction process organized more cautiously, one trade would complete its work before the next began, moving through the building in a single, sequential wave from foundation to roof. Such an approach would have taken years rather than months, an unacceptable pace for a project committed to opening within little more than a year of its groundbreaking. Instead, the building was treated less as a single continuous task and more as a series of overlapping bands, each trade following the one before it at a measured distance, so that on any given day, riveters might be working near the top of the frame, while masons closed in exterior walls 20 or 30 floors below them. And below the masons, electricians pulled wire through conduits already secured to the completed steel. And below the electricians, plumbers connected risers that had been left open and waiting since the floor was framed. The building rose, in effect, as several buildings rising simultaneously within the same shell, each trade a few weeks behind the one above it, each following the same design that had been settled before construction began, so that no trade needed to wait for architectural decisions to be finalized on the floor it was working on, because those decisions had already been made months earlier and distributed to every contractor in the form of drawings that left little room for improvisation or delay. Central to making this overlapping schedule possible was a commitment to standardized components wherever standardization could be achieved without compromising the building's design. Steel members were fabricated off-site according to precise specifications, cut and drilled to exact dimensions before ever arriving at the construction site, so that when a piece of steel reached the building, workers needed only to lift it into position and secure it, rather than shaping or modifying it on site, as earlier construction methods had often required. This same logic extended to other materials as well. Window frames, radiator units, and countless smaller fittings were manufactured in advance to consistent specifications, allowing them to be installed quickly and interchangeably across many floors without requiring custom fitting for each individual location. The uniformity of the building's floor plans, repeated with only minor variation through most of its height, made this standardization possible in the first place, since a design that varied significantly from floor to floor would have required different components at every level, undermining the efficiencies that repetition made available. The architects had embraced this repetition deliberately, understanding that a design capable of being built quickly needed to minimize the number of unique conditions a construction crew would encounter as it moved from floor to floor, and that elegance in a project of this scale might be found as much in disciplined repetition as in ornamental variety. The scheduling that coordinated all of this, later studied by planners and engineers as an early example of organized construction management, rested on a level of advanced planning that few building projects before it had attempted with such rigor. Every trade's daily progress was tracked against a master schedule that anticipated, weeks or months in advance, exactly which floors would be ready for which type of work on any given date. Materials were ordered and delivered according to this same schedule, timed to arrive not long before they were needed. Since a construction site with limited staging area on a crowded Manhattan block could not afford to stockpile materials for future phases of work, when it barely had room to store what the next several days required. This need for precise timing extended even to something as basic as the delivery of steel itself, which arrived from mills and fabricating shops on a schedule coordinated so closely with the pace of erection that steel members were sometimes lifted into place within hours or days of reaching the site, rather than waiting in a stockpile for their turn. The logistics of this coordination, involving dozens of contractors and subcontractors, thousands of individual workers, and a constant flow of materials arriving from multiple states, required a level of communication and record-keeping that had few precedents at the time, and the success of the schedule became, in later decades, a subject of study for those interested not in the building's architecture, but in the discipline of managing large and complex projects toward a fixed and demanding deadline. What made this internal choreography remarkable was how little of it registered with the public who watched the building rise from the street below. The steel frame offered a visible measure of progress, a new floor of columns and beams appearing against the sky every few days. A spectacle that photographers and reporters could document and readers could follow with a sense of mounting anticipation. The systems rising within that frame offered no comparable spectacle. No one stood on the sidewalk to watch a plumber connect a length of pipe on the 40th floor. And no newspaper photographed the electricians running conduit through a wall that would soon be sealed behind plaster and paint. Yet without this less visible work, keeping pace with the steel above it, the frame's rapid rise would have accomplished little beyond an impressive skeleton, a building that looked complete from a distance while remaining unusable at street level and every level above it. The speed for which the project became famous depended as much on the plumbers, electricians, and elevator mechanics working in near anonymity behind the rising columns as it did on the riveters, whose work could be seen and celebrated from blocks away. It was this quieter discipline, this willingness to plan every internal system with the same rigor applied to the frame itself, that allowed the building to open not merely as a tall structure, but as a functioning one, ready to receive tenants into offices with working lights, running water, and elevators capable of carrying them to floors that, only months earlier, had existed nowhere but on a drafting table. By the time the frame reached its final stages, the rhythm of the site had become so steady, so practiced, that the workers themselves had grown almost accustomed to the extraordinary. Floors that had once been announced with something like wonder were now simply logged, measured, and left behind for the next. It was in this atmosphere of quiet momentum, rather than mounting anticipation, that the topping out arrived in the spring of 1931, a ceremony that marked not the building's completion, but the completion of something more specific and, in its way, more fundamental: the steel skeleton itself, risen at last to its full and final height. The topping out of a steel structure carries with it an old tradition, one that predates the skyscraper by centuries, reaching back to the timber-framed halls of Northern Europe, where a branch or a small tree was fixed to the last beam raised into place, a gesture meant to appease the spirits of the forest for the wood taken to build the structure. and to wish good fortune upon those who would live beneath its roof. That tradition had traveled, as such things do, across oceans and centuries, transforming along the way, until by the early 20th century, it had become customary for American ironworkers to mark the setting of a building's final steel member with a flag rather than a branch, run up a short staff and fixed to the beam before it was hoisted into place, so that it might fly, briefly from the highest point the structure would ever reach during its construction. For the building rising on the site of the old Waldorf Astoria, this ceremony arrived after a period of construction that had already begun to seem, even to those close to it, faintly unreal in its speed. The steel had gone up floor after floor with a regularity that engineers elsewhere studied and would continue to study for decades. A pace made possible by the careful sequencing described in earlier stages of the work, by the derricks that climbed the frame as it rose, by the fabrication shops turning out beams, cut and drilled to exact specification, and by the riveting gangs whose coordinated labor had become, by this point in the project, something close to a settled science. Yet knowing the mechanism behind the speed did little to diminish the sense, among those who paused to look up, that something remarkable was occurring. The frame had climbed past the height of buildings that had themselves once seemed impossibly tall, past the cornice lines of neighboring towers, past the level where the city's older rooftops receded into a kind of second, lower skyline, and had continued rising still until it reached a height that placed it, if only for a matter of weeks, above every other structure built by human hands. The final beam, when it came time to raise it, was treated with a modesty that might surprise those accustomed to grander images of the era's engineering triumphs. There was no elaborate stage built for the occasion, no orchestra summoned to the site, no lengthy program of speeches read aloud to an assembled crowd. The ceremony that marked the steel frame's completion in the spring of 1931 was, by most accounts, brief and largely functional, conducted with the same unadorned efficiency that had characterized the construction as a whole. The beam itself, painted or left in its natural grey, was fitted with a small American flag before being lifted by derrick to its place at the summit of the frame, there to be bolted and riveted into position alongside the members already set. Photographs taken from the ground and from nearby rooftops, still capable of offering a vantage point, show the beam suspended against the sky, the flag catching whatever wind moved across the top of Manhattan that day, a small bright mark against the pale grey of the steel and the paler grey of the clouds beyond it. Those present for the moment, a mixture of ironworkers, foremen, engineers, and a handful of officials representing the building's ownership, are described in the surviving accounts not as jubilant but as quietly satisfied, their reactions restrained in a manner consistent with the broader temperament of the job. This was, after all, a workforce accustomed to danger treated as routine, to heights regarded not with fear, but with the practiced indifference of long familiarity, and to milestones that arrived, one after another, at a pace too rapid to allow for prolonged celebration. There is little evidence of raised voices or extended applause. What emerges instead, in the photographs and the brief written notices of the day, is something closer to a collective exhale, a recognition, shared without much need for words, that a difficult and dangerous phase of the work had reached its natural end. For the engineers overseeing the project, the topping out carried a different weight than it did for the men who had spent the preceding months walking the beams. It represented the successful conclusion of the structural calculations that had governed the building's design from its earliest sketches. The loads correctly distributed, the columns properly aligned, the wind bracing sufficient to hold the frame steady against forces it would face for decades to come. To reach this point without structural failure, without a serious miscalculation revealing itself partway through construction, was itself a form of vindication, though one expressed in the manner of the profession, through careful notation in reports and drawings, rather than through any public display of relief. If there was pride among the engineers that day, it was pride tempered by the awareness that the frame's completion, however significant, marked only one phase of a larger undertaking still very much in progress. For beneath the ceremony, and beyond the brief moment when the flagged beam caught the light above the city, an enormous quantity of work remained. The steel frame, complete as it now stood, was in essence a skeleton, an armature of columns and beams and diagonal bracing capable of bearing loads and resisting wind. But entirely without the skin, the interior substance, or the mechanical life that would eventually make it habitable. The masons who had been following the frame's ascent, setting brick and limestone cladding onto the steel some 10 to 20 floors below the topmost columns, still had a considerable distance to climb before the building's exterior would be complete from base to summit. The limestone panels, quarried and cut according to the specifications described earlier in the building's material history, continued to arrive by rail and truck in a steady procession, to be lifted and set with the same disciplined choreography that had governed every other stage of the project. Inside the frame, the work of transforming empty steel bays into functioning floors had been proceeding in tandem with the frame's rise. But a great deal remained even after the topping out. Plastering, flooring, the installation of partitions, the fitting of doors and hardware, the countless small finishing details that separate a structural shell from a livable space. The elevator installations, among the most technically demanding of the building's systems, required extensive testing and adjustment even after the shafts themselves had been completed, ensuring that the cars could move safely and efficiently between floors that in some cases numbered more than 80 above the street. The plumbing and electrical systems described in earlier stages of the project's development continued to be threaded through walls and floors in the levels below the summit, even as work at the very top of the building turned to a feature that had captured public attention perhaps more than any other single element of the design. That feature was the mooring mast, the tall spire intended, according to the building's original conception, to serve as a docking point for airships, a proposal that had generated considerable public discussion in the months leading up to construction, and that required, at the summit of the now complete steel frame, its own separate phase of assembly. The mast rose above the topped-out frame in the weeks following the ceremony, a slender addition crowning the building's broader mass, designed to extend the structure's overall height by a significant margin, and to provide, whether or not it would ever truly serve its stated aeronautical purpose, a distinctive silhouette that would set the building apart from its rivals along the skyline. The construction of the mast proceeded with the same careful attention to safety and sequencing that had marked the frame below it, though on a smaller scale, involving fewer workers and less material, its slender steel members rising against the sky like a needle atop the broader tower. It was against this backdrop of continued labor, masons setting stone, electricians threading wire, engineers testing elevator mechanisms, ironworkers assembling the mooring mast above the completed frame, that the full scope of the project's timeline became, in retrospect, almost difficult to credit. From the day the excavation had begun, clearing away the remnants of the old hotel that had once stood on the site, to the point at which the building stood substantially complete, ready to open its doors to tenants and visitors, the elapsed time amounted to approximately 410 days. Within that span, a building rising more than 1,000 feet into the air, encompassing more than 3.5 million square feet of interior space, had been excavated, framed, clad, wired, plumbed, and finished. A pace of construction that would be remarked upon by engineers and historians for decades afterward as a singular achievement of coordination, planning, and disciplined labor. The topping out in the spring of 1931 had marked the moment when the frame reached its full height. But the 410 days that bracketed the entire undertaking, from bare earth to substantially finished tower, remained the figure that would come to define the project in the memory of those who studied it afterward. A number that seemed, even to those who understood every stage of the process that produced it, faintly impossible. What emerged from the scaffolding that spring was a building that revealed itself slowly, the way a face emerges from mist, level by level, until the whole structure stood clear against the sky. To walk toward it along Fifth Avenue in those first months after completion was to watch it change with distance and angle, the lower floors offering one impression and the tower above offering another. The two joined by a series of setbacks that carried the eye upward in measured stages rather than a single unbroken sweep. The setbacks were not ornamental afterthoughts. They had been required by the zoning laws that governed New York's growing towers, laws written a decade earlier to ensure that light and air still reached the streets below, even as buildings climbed higher than anyone had once thought reasonable. The architects had turned that requirement into a rhythm, stepping the building back at the fifth floor, then again higher up, and again as the tower narrowed toward its crown, so that the setbacks read not as compromises, but as a kind of visual breathing, a structure that seemed to inhale as it rose. At street level, the building met the city first through its base, a limestone and granite face quarried and cut with the same patience that had governed every other stage of the work. The stone had been chosen with care, a pale grey limestone from Indiana forming the bulk of the surface, accented with granite at the base where pedestrians would pass closest and where the stone needed to withstand the daily friction of a city's foot traffic. The masons who had set that stone, working in close coordination with the riveters far above them, had left a facade that read as solid and unbroken, though it was in truth a skin draped over a steel skeleton, thin enough in places to be measured in inches, its true strength residing entirely in the frame it concealed. This was the paradox that any careful observer of the finished building came to understand. The massive, permanent-seeming stone that gave the tower its visual weight was not what held it up at all. The steel did that, invisible beneath the surface, and the stone was simply what the city was permitted to see. Inside, past the revolving doors, the lobby offered a different register entirely, an interior conceived in the Art Deco manner that had become the architectural language of the age. All geometric pattern and polished surface, marble walls rising toward a ceiling worked in metal and colored stone. The whole space designed to announce, quietly but unmistakably, that this was a building of consequence. The materials had been selected for their permanence as much as their beauty, marble drawn from quarries in France, Belgium, Italy, and Germany, laid in patterns that caught the light differently through the course of a day. Aluminum and steel appeared throughout the decorative metalwork, materials that spoke to the building's structural nature, even in its most ornamental spaces, as though the architects wished the lobby to whisper what the frame above shouted. A visitor walking through those halls in the summer of 1931 would have found a hush appropriate to a cathedral, footsteps softened by the scale of the space, voices lowered without instruction, the sense of having entered somewhere that asked for a kind of reverence. The building's dimensions, when set down plainly, carried their own quiet weight without needing embellishment. The tower rose some 381 meters to its main roof, and considerably higher still when the mooring mast at its summit was included in the reckoning, a height that made it, upon completion, the tallest structure ever raised by human hands, surpassing the Chrysler Building that had held that distinction for scarcely more than a year. It contained some 102 stories, depending on how one counted the mast levels above the main roof, and enclosed something in the neighborhood of 200,000 square meters of floor space, distributed across a footprint that occupied the better part of a full city block along Fifth Avenue between 33rd and 34th Streets. The steel frame alone had consumed roughly 57,000 tons of material, assembled from pieces fabricated in mills and shops scattered across several states, and delivered to the site with the choreographed precision that had allowed the building to rise at its extraordinary pace. 67 elevators moved through the building's core, a number that had seemed, to some observers at the time, almost extravagant, though the building's eventual scale of occupancy would prove the figure entirely necessary. These numbers, recited without excess emphasis, were not offered as boasts. They were simply what the building was, set down as fact, the way one might describe the dimensions of a mountain or the depth of a river, features of the world rather than achievements to be marveled at on their own terms. Though the marveling came anyway, quietly, to anyone who paused to consider them. At the very top, above the setbacks and the observation floors, rose the mooring mast, a structure whose stated purpose had been to serve as a docking point for airships. A vision of the future that imagined dirigibles crossing the Atlantic and mooring at the summit of Manhattan's tallest tower before discharging their passengers down through the building itself. The idea had captured public imagination, even as engineers privately understood its practical limitations. The winds at that height and the maneuvering difficulties of large airships near tall buildings, making any regular mooring service unlikely. The mast was used only once, briefly and experimentally, for a small airship that managed to deliver newspapers and little else. And the grander vision quietly faded from serious consideration within a few years. What remained, however, was an observation deck positioned high above the city, offering a view that no one in New York had ever been able to see before from a fixed structure. A vista that took in the rivers on both sides of the island, the bridges strung across them, the lower buildings of the financial district to the south looking suddenly modest, and on clear days, the countryside beyond the city's edges, visible at a distance that had previously belonged only to aviators. Visitors who climbed to that height in the building's early months described the sensation in similar terms, a kind of vertigo mixed with wonder. The ordinary points of reference by which a New Yorker understood the city, the street corners and familiar roof lines, rendered suddenly small and abstract. A puzzle picture rather than a city, so that seeing it required a kind of relearning, an adjustment of scale that took some minutes to settle into the mind. The building opened formally on the 1st of May in 1931 with a ceremony that drew considerable attention, the sort of civic occasion that the city still knew how to stage, even as its economic circumstances had darkened considerably since the project's inception. The stock market's collapse in the autumn of 1929 had occurred while the building was still in its planning stages, and by the time construction reached its peak, the country had settled into the early, worsening years of what would come to be called the Great Depression. The men who had raised the steel, walking the beams with the same steady competence, regardless of what the newspapers reported about bank closures and rising unemployment, had in some sense built the tower through the Depression's opening chapter, a fact that gave the finished structure an odd and layered significance in the public mind. Here was a monument to ambition and capital, rising at the very moment when ambition and capital seemed, across much of the country, to be in retreat. The opening ceremony itself carried a note of triumphant civic pride. Dignitaries and photographers gathered, ribbons cut, the building formally declared open to the public and to the tenants who were expected, in the ordinary course of business, to fill its floors. The public reaction in the days and weeks that followed was one of genuine awe, tempered by the sober economic mood that hung over the city and the nation. People came to see the building, to stand at its base and crane their necks upward, to ride its elevators to the observation deck and look out over a metropolis they had never before seen from such a height. And the sense of wonder in those visits was recorded again and again in the accounts that survive, a kind of collective astonishment that the age, for all its troubles, had managed to produce something of this scale and ambition. Yet beneath that public wonder lay a quieter and more difficult truth, one that would shadow the building for much of its first decade. The tower had been conceived and financed in an economic climate entirely different from the one into which it was born, and the office space it offered, however impressive, found the market for such space collapsed by the very depression that had settled over the country during its construction. Tenants proved slow to arrive. Floor after floor stood empty in the months and years following the opening, the building's vast interior far outpacing the demand that existed to fill it, so that observers who understood the city's commercial real estate began to speak of it, half in jest and half in genuine assessment, as the empty state building, a bitter little pun that captured the irony of the moment precisely. Here was an empire of steel and stone, risen at extraordinary speed through an unprecedented feat of coordinated labor, standing as the tallest thing ever built by human hands, and finding itself, in its earliest years, more populated by tourists riding the elevators to the observation deck than by the office tenants whose leases were meant to sustain it. The building's income during those years came disproportionately from ticket sales to sightseers rather than from rent, an irony not lost on the men who had financed the project with grander commercial ambitions in mind. It would take years, and the slow national recovery from the Depression's worst chapters, before the tower's floors filled in earnest, before the empire it represented found tenants sufficient to match the scale of what had been built. But even in those lean years, standing largely unoccupied against the Manhattan sky, the building held its place as the tallest structure on Earth, a distinction that no vacancy could diminish, and one that would remain unchallenged for decades to come. The years that followed brought tenants slowly, then steadily, then in a flood that no one in 1931 could have predicted. Small manufacturers took modest suites on the middle floors. Import firms, insurance offices, and law practices settled into corridors still smelling faintly of fresh plaster. By the close of the 1930s, the building had begun to earn its keep, not through the vast anchor tenants its builders had once imagined, but through the accumulation of hundreds of small businesses, each renting a few rooms, each contributing a modest sum that together amounted to something like prosperity. The observation deck, meanwhile, had already begun its own quiet transformation from architectural afterthought to essential attraction. Visitors arrived by the thousands, then by the millions, ascending in elevators that had been designed for speed and dignity in equal measure, stepping out onto the open deck to look down upon a city that seemed, from that height, to have been rendered in miniature. The building had been conceived as an address for commerce. It became, almost without anyone intending it, a destination in its own right, a place where the ordinary act of looking out over a horizon became something closer to ritual. The building's presence in the visual record of the 20th century grew alongside its life as a workplace and a landmark. Photographers found in its silhouette a shorthand for the city itself, a single image capable of standing in for the whole idea of New York. Filmmakers discovered the same thing. The tower appeared in newsreels and features, its distinctive crown recognizable even in the grainy black and white of early cinema. And in the decades that followed, it would appear again and again in dramas and comedies, in disaster pictures and quiet character studies, until the building's outline became one of the most reproduced architectural images in the world. It did not seek this role. It simply stood, tall and legible against the sky, in a city that photographed itself constantly, and photographers and filmmakers, needing a symbol that required no explanation, returned to it again and again. The tower that had been built to prove a point about height became, gradually and without any single deciding moment, a kind of shorthand for the city that had built it. The systems within the building did not remain static across these years. The elevators that had impressed visitors upon opening were themselves the product of an era's engineering, and as decades passed, the machinery that moved passengers between the lobby and the observation floors required updating, replacement, and eventually wholesale modernization. Cables were changed, motors upgraded, control systems replaced, as the mechanical language of vertical transportation evolved far beyond what the original engineers could have specified. The building's systems of heating, cooling, and electrical distribution underwent similar transformations. Each generation of tenants requiring accommodations the original design had not anticipated. Each decade bringing technologies that had to be threaded carefully through a structure never intended to house them. Windows were replaced. Wiring was reconfigured. The bones of the building, the steel frame that had risen so quickly in 1930 and 1931, remained essentially unchanged, carrying loads exactly as it had been calculated to carry them. But the flesh around those bones, the systems that made the building livable and useful to each new generation of occupants, was renewed continually, quietly, without any single dramatic overhaul, in the manner of an old structure that adapts by increments rather than by revolution. Among the alterations that came to define the building's later character were the lighting installations that transformed its upper floors into a kind of civic instrument. Beginning in the middle decades of the 20th century, the building's owners and operators began to illuminate the tower's crown in colors chosen to mark particular occasions, a practice that started modestly and grew, over the years, into an elaborate and much anticipated tradition. Red and green appeared at Christmas. Orange and blue marked civic celebrations. Colors shifted to honor holidays, to commemorate tragedies, to celebrate visiting dignitaries or civic anniversaries, until the building's illuminated crown became a kind of calendar visible across the city, a way of reading the date and the mood of the moment simply by looking up. What had begun as a functional necessity, the placement of aviation warning lights atop the tower's highest point, evolved into something closer to art, a slow-changing display that required no explanation to those who lived beneath it, and that gave the tower a second life as a kind of civic clock, marking the passage of the calendar year in colored light rather than in numbers. It was in the fog of a Saturday morning in the middle of the 20th century that the building endured the most severe structural test of its existence, one that no engineer in 1930 had planned for, and one that arrived without warning on an otherwise unremarkable day. A military aircraft, flying in conditions of poor visibility, struck the building's north side near its 79th floor, the impact tearing a gash in the exterior wall and starting a fire that burned for a brief but intense interval before being brought under control. The accounts that survive describe the damage with a plainness that belies the violence of the event. A hole torn through masonry and steel, an elevator shaft compromised, a number of lives lost among those working in the building at the time, and a fire that scorched several floors before firefighters, arriving with the speed the building's central location made possible, extinguished the flames. What the accounts also make clear, and what engineers who studied the incident in the years that followed have confirmed repeatedly, is that the building's structural frame, the riveted steel skeleton raised so quickly 2 decades before, absorbed the impact without compromising its overall integrity. The damage was severe but contained, limited to a handful of floors, and repairs were undertaken with an efficiency that matched the pace of the original construction. Within a matter of months, the affected floors had been restored, the building reopened to its full function, and the incident receded into the record as a testament less to catastrophe than to the soundness of a structure that had been built, from its earliest days, to carry loads and withstand forces far beyond what any ordinary tenancy would demand. The frame that had gone up in 410 days had been asked, unexpectedly and violently, to prove its worth once more, and it had done so. Across the decades that followed, the building settled into a rhythm that combined ordinary commercial life with an increasingly prominent role as cultural touchstone. Office tenants came and went, industries shifted. The composition of the businesses housed within its walls changed with the changing economy of the city and the nation. But the building itself continued its function largely unaltered. A vertical village of small enterprises going about their business many hundreds of feet above the street. Meanwhile, its identity as landmark and symbol only deepened. Couples were married within sight of its observation decks. Visitors from every part of the world made the ascent a fixed point on their itineraries. The building appeared on postcards, on posters, on the covers of magazines, its image so thoroughly absorbed into the visual vocabulary of the city that it became difficult to imagine the skyline without it. Difficult to remember that it had once been merely one ambitious project among several competing for the title of tallest in the world. The lights atop its crown continued to mark the seasons and the civic calendar, a quiet tradition renewed year after year, decade after decade, requiring no announcement because by then everyone understood what the colors meant. What is perhaps most striking, considered across the near century of the building's service, is not any single transformation, but the accumulation of small adaptations that allowed a structure completed in 1931 to remain useful, relevant, and structurally sound into an era its original builders could scarcely have imagined. The elevators were replaced. The systems were modernized. The observation decks were renovated to accommodate ever larger crowds. The lighting was upgraded from simple colored gels to sophisticated computer-controlled displays capable of rendering millions of colors and patterns. Through all of this, the steel frame beneath the modernized surfaces remained the same frame that had risen through the winter and spring of 1930. Carrying the same loads according to the same calculations. Proof that a structure built with sufficient patience and sufficient rigor could serve one purpose in one century and adapt, gracefully and repeatedly, to serve entirely different purposes in the century that followed. The building had been raised as a wager on height and ambition. It endured across nearly 100 years as something quieter and perhaps more remarkable. A structure that simply continued to work, one renewed system at a time, one illuminated evening at a time, long after the wager itself had been settled and forgotten by all but the historians who still consulted the record. No structure rises without ancestors, and the tower on Fifth Avenue had a lineage it never tried to disguise. Long before its steel had been ordered, before Raskob had drawn his pencil upward on a scrap of paper to ask how tall a building might go, there had been other towers reaching for the same unclaimed altitude, each one certain for a season that it had settled the question. The Woolworth building, completed in 1913, had stood at a little over 790 feet, its Gothic ornament dressing a steel frame in the borrowed language of cathedrals. And for nearly 2 decades it held the title of tallest building in the world with a kind of settled confidence, as though the record itself had found a permanent home on Lower Broadway. It was called, in its own time, the Cathedral of Commerce, a phrase that captured precisely the strange marriage the age had made between reverence and enterprise. Then came the contest of 1929 and 1930, when the record loosened and began to move quickly between buildings still under construction. Each architect and financier watching the other's steel rise in the newspapers with an attentiveness that was never quite admitted aloud. 40 Wall Street reached for the title. The Chrysler Building, with its spire assembled in secret within its own fire shaft and raised into place in a matter of hours, took the record from all of them, if only for a matter of months, its stainless steel crown catching light in a way no building had managed before. And then the Empire State Building had risen past it, past all of them, reaching 1,250 feet to the roof and higher still with the mooring mast, and had done so not in the leisurely span of decades that the Woolworth Building's reign might have suggested was customary, but in 410 days of steady, disciplined construction. The record had moved rapidly in those years, building to building, almost as though height itself had become a fluid thing, held only briefly by whichever structure could claim it before the ink dried on the next set of drawings. The Empire State Building, when it finally stood complete, seemed for a moment to still that motion entirely. It held the title of tallest building in the world for nearly 40 years, a span so much longer than its immediate predecessors had managed that it came to feel, to a generation of New Yorkers and to visitors arriving by ship and by train, less like a temporary victor in an ongoing contest, and more like a fixed point against which the city's other ambitions would always be measured. That long reign ended in the early 1970s, when the towers of the World Trade Center rose in Lower Manhattan. Their flat, minimal steel and glass forms a deliberate departure from the ornamented masonry and setback massing that had defined the earlier generation of towers. The North Tower reached 1,368 feet, surpassing the Empire State Building's roof height by more than 100 feet. And the record moved downtown for the first time since the contest of 1930 had settled it uptown. It was, by most accounts, a quiet transfer rather than a dramatic one. There was no race this time, no competing steel crews watching each other's progress from adjacent blocks, no newspapers tallying floors added by the week. The record simply passed, as records eventually do, to a structure built with different methods, different materials, and different assumptions about what a tall building was for. The Sears Tower in Chicago claimed the title after that, its bundled tube structural system representing an engineering approach the riveted frame of 1930 could not have anticipated. And after Chicago, the record moved further still, to towers in Kuala Lumpur, and then to Taipei, and eventually to Dubai, where the Burj Khalifa rose past half a mile into the air using slip-formed concrete and a buttressed core that would have seemed, to the men who had wrestled steel columns into place above Fifth Avenue, like a description of some future so distant it barely qualified as engineering at all. The Empire State Building, once the undisputed summit of human construction, settled quietly into a lower position on the list. No longer the tallest anywhere, not even the tallest in its own city after the Trade Center's completion. And yet, it never became merely another building in the way that so many former record holders eventually do. It kept its name. It kept its silhouette on the skyline, recognizable from a distance in a way that few of the towers that surpassed it in height ever quite matched. Height, it turned out, had been only one part of what the building had achieved, and perhaps not even the most durable part. The engineers and architects who came after Shreve, Lamb and Harmon studied the Empire State Building's construction with a scrutiny that outlasted its record for height by decades. Because what interested them was not simply how tall the tower had gone, but how quickly and how precisely it had gotten there. The empirical formula the firm had developed, tying every design decision to cost and time as rigorously as to appearance, became something close to a case study in engineering schools. An early and unusually well-documented example of a building conceived from its outset as a coordinated system rather than an assembly of separately solved problems. The choreography that had carried steel from the mills of Pittsburgh to a beam bolted into place above Manhattan within roughly a day and a half. The modular division of the tower into repeated, typical floors that could be assembled by crews who came to know their sequence by rote. The careful staging of hoists and material deliveries that kept a site of only 2 acres from ever choking on its own deliveries. These were the elements later builders returned to, again and again, whenever a new project's schedule demanded that a great deal of building happen in very little time. The idea of the tall building as a repetitive, modular structure, its typical floors designed once and then built dozens of times in succession, became a foundation of skyscraper construction for the rest of the century. visible in towers that otherwise looked nothing like the setback massing of 1930. Even the logistics of a constrained urban site, solved originally out of necessity on a block that could not be widened, no matter how much steel needed to move across it, became a template that later builders in London, in Hong Kong, in Chicago, consulted when facing their own crowded footprints. The building had been raised in a hurry, under financial pressure that left the developers no room for a slower, more contemplative pace. But the record it left behind of exactly how that hurry had been managed, exactly which decisions had saved a day here and a week there, became a kind of instruction manual that outlived the very urgency that had produced it. It is the number itself, more than any particular technique, that later builders have returned to with something like quiet disbelief. 410 days, most of it spent raising more than 102 stories of steel and stone and finishing them completely enough to open for occupancy, remains a pace that few comparable projects in the intervening century have matched, and fewer still have matched, while working with tools as limited as those available in 1930. Modern towers, built with tower cranes capable of lifting loads, the derricks of that era could not have imagined, with computer-modeled logistics and prefabricated components engineered off-site to tolerances undreamed of by riveters working from paper templates, routinely take years longer to complete structures of comparable or lesser scale. Engineers who have studied the schedule in detail have noted, with the sort of restraint that disguises real astonishment, that the speed was achieved not through shortcuts, but through an almost obsessive attention to sequencing, an insistence that every trade know exactly where it needed to be and exactly what needed to be finished before it could begin. There is no simple explanation for how a crew working with cranes fixed to the building itself, moved upward floor by floor, managed to outpace projects built nearly a century later with vastly more capable equipment. The comparison has become something of a quiet fixture in engineering literature, cited not to diminish modern methods, but to illustrate how much of construction speed depends on discipline and coordination rather than on machinery alone. The contest to build higher did not end with the Empire State Building, and it has not ended since. It has simply moved, decade by decade, across oceans and continents, carried by whichever city or nation found itself, in a given era, possessed of the capital and the ambition to reach further than the one before it. New York held that ambition in 1930. Chicago and then Kuala Lumpur and Taipei and Dubai have each held it in turn since, and there is no reason to think the contest has reached its final chapter. And yet the tower on Fifth Avenue, no longer tallest anywhere, no longer even a contender in that particular race, has never receded into the position that the fate of most former record holders would seem to guarantee. It remains, nearly a century after its steel was closed, at the 86th floor, one of the most recognized silhouettes ever raised against a sky, not because it still holds the record it once claimed in 410 days, but because the record, once won and then surrendered, turned out to matter less than the structure had itself become. By the middle years of the 20th century, the building's steel had already outlasted the ambitions that raised it. But outlasting is not the same as remaining unchanged, and those who came afterward, engineers and preservationists and quiet men with clipboards who walked the setbacks and the mechanical floors, understood that stewardship of such a structure was itself a kind of ongoing labor, unglamorous and largely unseen, much like the labor that had built it in the first place. The windows were among the earliest and most visible signs of this second, gentler kind of construction. The original steel frame windows, set into the limestone and granite facing during those 14 months of 1930 and 1931, had served for decades. But by the 1960s, the wear of weather and use had made itself known in drafts and leaks, and the accumulated fatigue of thousands of opening and closing cycles across more than 6,000 individual units. The building's owners undertook a full replacement, installing aluminum-framed windows in patterns that preserved the original proportions, so that from the street the change was almost invisible, and the tower's face, to anyone glancing up from Fifth Avenue, appeared exactly as it always had. This was, in its way, a philosophy stated in glass and metal rather than in words. That the building's outward character was to be protected, even as its inward workings were renewed. That the appearance of permanence could be honestly maintained through the honest replacement of parts that permanence itself had worn away. The lobby received a similar attention, though its history was more contested. The original interior, finished in 1931, with marble quarried from France and Germany and Italy, with aluminum reliefs depicting the building itself rising in stylized rays of light, with a ceiling mural intended to evoke the heavens above a structure that had briefly touched them, had been altered across the decades in ways that later generations came to regret. Renovations in the mid-20th century had covered some of the original ornamentation, had introduced elements at odds with the building's Art Deco language, had, in the accumulated judgment of preservation architects working many decades later, diminished a space that had been conceived with as much care as the frame rising above it. In the early years of the 21st century, a careful restoration was undertaken, one that studied historic photographs and original drawings and fragments of the initial finishes still hidden beneath later editions, and worked to recover the lobby's original character without pretending that no time had passed at all. The aluminum sunburst reliefs were restored. The mural depicting the building at the center of its own cosmology of light and industry was cleaned and, where necessary, recreated according to the surviving evidence. This was not an attempt to erase history, but to recover a particular layer of it, the layer that had been judged, on reflection, to be the truest expression of what the building had meant to say about itself. Alongside these visible renewals came a body of structural assessment, less visible to any visitor walking through the lobby or riding the elevators, but no less significant to the building's long life. Engineers returning to the original design decades later, armed with analytical tools the 1930s builders could not have imagined, examined the steel frame's capacity against modern codes for wind load and seismic performance, and simply asked, in effect, whether the tower still met the standards a new building would be required to meet. The findings, repeated across several such studies conducted over the decades, were consistent in their central conclusion. The original design, worked out by hand and slide rule under Homer Gillette Balcom's direction, had been conservative in its assumptions and generous in its margins, sufficiently so that the frame required little structural intervention to satisfy contemporary safety standards. Where reinforcement was undertaken, it was often modest, addressing specific elements or bringing certain connections into closer alignment with updated codes, rather than reflecting any fundamental inadequacy in what had been built. This was, to engineers studying the matter, a quiet vindication of a design process that had proceeded, by necessity, without the computational modeling that later generations would take for granted, relying instead on calculation, precedent, and a professional caution that erred toward strength rather than economy wherever the two came into tension. It is worth pausing on this point, because it is one that has drawn its share of wonder from later historians and engineers who have gone back into the archives, into the surviving correspondence and shop drawings and the records of the fabricating plants, and tried to reconstruct exactly how so vast an undertaking was coordinated in an age before computers, before digital scheduling software, before any of the tools that would now be considered indispensable to a project of comparable scale. What they have found again and again is not evidence of improvisation, but evidence of a system, worked out through experience on earlier towers and refined through the particular discipline that Starrett Brothers and Eakin brought to this site, in which paper and telegraph and telephone and a small army of expediters carried information with a speed and accuracy that modern engineers, used to instantaneous digital communication, have found genuinely remarkable to reconstruct. The scheduling boards that tracked deliveries, the color-coded systems that identified which floor's steel was where in its journey from mill to erection, the daily meetings that adjusted the following day's work against the previous day's progress. All of this constituted a form of project management that, while lacking the vocabulary and software of later decades, achieved outcomes that later projects, for all their added technology, have not always matched. Several historians of construction have noted, with something like professional admiration crossing into quiet astonishment, that the Empire State Building's rate of rise, roughly 1.5 stories a week sustained across months, remains a benchmark against which later steel frame projects are still sometimes measured, and that matching it today, even with modern cranes and modern software, is by no means guaranteed. This admiration has, over the years, curdled at times into exaggeration, and it is worth setting the record straight where legend has outpaced documentation. The claim that the building was completed entirely without serious injury, sometimes repeated as though it were an established fact, does not withstand comparison against the payroll and insurance records that survive from the project, which show that injuries, some of them serious, did occur across the many months of work as they occurred on every large steel project of the era. The more accurate claim, and the one the surviving records support, is that fatalities were fewer than popular fear, and press speculation had anticipated for a project of this height and pace, a fact remarkable in itself without needing to be inflated into a claim of a project entirely without harm. Similarly, the number of workers reported as having died during construction has been stated with a confidence in various retellings that the surviving documentation does not entirely support. The estimates offered by different sources have varied, and diligent historians examining hospital records, newspaper accounts, and company files have generally urged caution rather than certainty on the exact figure, noting that record-keeping practices of the period were not always thorough or consistent, particularly regarding injuries that occurred off the specific worksite or in the months following an incident. The building's completion under budget and ahead of schedule, often repeated as a triumphant footnote, is well supported by the documented costs and the construction timeline. But the reasons for it, chiefly the collapse in labor and material costs, brought on by the depression that had settled over the country, even as the tower rose, are less frequently mentioned alongside the boast, though they belong beside it, if the record is to be told honestly. None of this diminishes what was achieved. It simply asks that the achievement be understood in its true dimensions, rather than in the rounded and simplified dimensions that legend, over 90 years, has sometimes preferred. The building's status as a landmark, meanwhile, has never required exaggeration to sustain it. It was designated a National Historic Landmark in the later decades of the 20th century, and a landmark under the protections of the city it has stood within since its earliest years. Designations that recognize not merely its height, long since surpassed by other towers around the world, but its architectural character, its historical association with the era that produced it, and its continued presence as a working structure rather than a preserved relic. It remains even now a fully occupied office tower, its floors leased to businesses whose employees pass daily beneath a lobby ceiling restored to its original brightness. Largely unaware, perhaps, of the 410 days of steel and rivet and human effort that made their commute possible. It is this dual life, as functioning workplace and as symbol recognized around the world, that has allowed the building to avoid the fate of monument reduced to mere image. It continues to be climbed, though now by elevator rather than derrick, continues to be photographed against every possible condition of light and weather, continues to appear as shorthand for the city itself, in film and photograph and memory, and continues through all of this to be exactly what it was built to be: a place where work is done, held up by steel that has proven, across 9 decades of study and reassessment, to be every bit as sound as the men who raised it believed it to be, though they had only their calculations, and not the certainty of hindsight, to reassure them at the time. There is a particular kind of silence that settles over a building once it is finished. A silence that has nothing to do with sound and everything to do with attention. For 410 days, the tower had been a place where something was always happening, where the clang of a rivet gun, or the shout of a foreman, or the groan of a hoist rising through the open frame gave the structure a voice of its own, a voice made entirely of labor. And then, gradually, that voice quieted. The derricks came down. The scaffolds were dismantled and carried away in pieces, the same way they had arrived. The men who had walked the beams found other beams, in other cities, on other jobs, because that was the nature of the work, and the tower they left behind settled into the long, wordless permanence that would define the rest of its life. What remains when the voice of construction fades is the thing itself. Steel and limestone and concrete, arranged according to calculations that have since been checked and rechecked by generations of engineers who were not yet born when the columns were first raised, and who found each time that the numbers held. It is worth pausing at the end of this account on what exactly those numbers represented and what they did not. A building of this height was not, in any simple sense, an act of faith. Every load path had been traced, every column sized to carry the weight above it, down through the frame and into the bedrock below Fifth Avenue. Every rivet placed according to a schedule that assumed wind, assumed settlement, assumed the ordinary stresses of a structure standing exposed above a city for decades to come. And yet no engineer, however careful, can eliminate the element of trust that accompanies any structure built for the first time at a new scale. The men who signed the drawings could not know, with the certainty available to their successors, exactly how their tower would behave over 90 years of wind and temperature and use. They knew what their calculations told them, and they knew the record of the buildings that had come before, shorter towers that had stood without complaint through their own decades of service. Beyond that, they were extending a line of reasoning into territory no one had occupied before, and trusting that the line would hold as well at 1,250 feet as it had at 800 or 600 or 400. It did. The trust was not misplaced. But it is worth remembering now, at the close of the story, that it was trust nonetheless, and not simple certainty, that carried the frame skyward. The names of the men who did the carrying are, for the most part, gone. This is not a failure of the record so much as a condition of the work itself. A payroll ledger records a name and a wage and a trade, riveter or bolter-up or heater boy, and sometimes a nationality, Mohawk or Irish or Italian or native-born New Yorker. But it does not record a face, a voice, a way of laughing, the particular rhythm with which a man crossed a beam 600 feet above the street. Photographs survive, some of them justly famous, men perched on girders with their lunch pails, men leaning into the wind with a grace that looks almost careless and was in fact the opposite of careless, the product of years of practiced attention. But even these photographs are, in the end, anonymous. We do not know in most cases which man in which photograph belongs to which name in which ledger. The tower stands as a monument to a labor force that built it collectively and disappeared from the record almost as completely as they disappeared from the site once the work was done. This is true of nearly every great structure raised before living memory, and it does not diminish the achievement to say so. If anything, it deepens it, because it means the building itself has become the only lasting witness to work that would otherwise have vanished entirely. The steel remembers what the ledgers could not be bothered to record. And the steel does remember, in its own way, not through consciousness, which it does not possess, but through persistence, which is a kind of memory available even to inert matter. Every column in that frame still carries today the load it was calculated to carry in the drafting rooms of 1929. Every rivet, cooled and set by a heater boy and a gang of 3, still holds the 2 plates it was driven to join, holds them with a grip that has not loosened across 90 years of wind and heat and settlement. The building does not know that it was built quickly, or that it was built in a race, or that the men who raised it worked 6 days a week for wages that would seem impossibly small by any later standard. It simply continues to do what it was built to do, which is to stand and to carry weight down to the ground with a patience that has nothing to do with intention and everything to do with the honesty of the calculations that gave it its shape. In this sense, the tower is less a monument to ambition than a monument to arithmetic, though it required both in equal measure, and it is difficult, standing at its base and looking up, to say with confidence which of the 2 mattered more. Picture it now as the story closes, in the hour just before the city fully wakes. The light comes low across the East River first, catching the tops of the buildings nearer the water before it reaches Fifth Avenue. And when it finally arrives at the tower, it does not strike all at once, but climbs the face of the limestone slowly, the way the construction itself once climbed, floor by floor, catching first the setbacks near the crown and then working downward through the long vertical run of piers toward the street. The steel behind the stone does not show itself at this hour, or at any hour, hidden as it has always been behind the limestone skin that was chosen precisely so that the frame beneath would never be seen, would never need to be seen, its work being structural rather than decorative. But the shape of the building, the narrowing rise toward the mooring mast, the long, steady climb of the setbacks, all of it traces the shape of the frame within, so that looking at the tower in this early light is, in a sense, looking at the steel indirectly through the stone that was fitted to its outline nearly a century ago. Somewhere below, at street level, delivery trucks are already moving, and somewhere within the tower itself, the first office lights are beginning to switch on floor by floor as the earliest workers arrive, carrying coffee and briefcases through a lobby whose materials were chosen with the same care as the frame above it. None of them, most mornings, will look up. This is not a failure of appreciation so much as the ordinary condition of a working building, which asks to be used rather than admired, and which the tower has been used daily for the entire span of its existence. But if one of them did look up on a morning like this one, they would see limestone catching gold and steel windows catching the same light in smaller, sharper reflections. And above it all, the long taper toward the mast where dirigibles were once meant to dock and never did. They would see, in other words, exactly what the men who built it saw when they finished, though those men saw it from the inside, from the derrick floor, in the last days before the scaffolding came down. That scaffold line is gone now, has been gone for 9 decades, dismantled piece by piece and carried away to other jobs, other cities, other frames rising in other places. There is no trace of it left on the building itself, no scar or seam to mark where the hoists ran, or where the derricks swung their loads from floor to floor. And yet, it is worth holding in the mind for a moment longer. That image of scaffolding climbing against the sky, timber and steel lattice reaching a little higher every week, carrying men and materials upward, along a path that no longer exists, anywhere except in photographs and in the memory of a story like this one. The scaffold was never meant to last. It existed only to make the permanent thing possible. And having done so, it vanished, the way the labor of construction always vanishes into the finished structure that outlasts it. What remains is the tower, and what the tower carries, in its steel and stone, is the record of that vanished scaffold, translated into permanence, holding still the shape of the work that once climbed toward the sky along a line that nothing now marks. If this story of steel and stone and patient calculation has been good company across these quiet hours, there are other structures waiting to be told in the same unhurried way. Other towers and bridges and tunnels raised by workers whose names have mostly slipped from the record, and you are welcome to find them here on the channel whenever you'd like to return. For now, though, let the tower stand in the early light, steel and limestone, settling into another ordinary day, and let yourself rest.